record on this computer. How do I make somebody else co-host so that, wait, actually, I should have done this in a different order because now that, okay, I need to stop share for a second. Let's make Alex the co-host so he can let people in um, because there's a whole bunch of people waiting.
Okay, now I can press admit all.
Yes. Okay, and now I can reshare my awesome screen. See, this is what like OOP does to me because I nearly went insane. So I had to do something to I don't know, like make it more interesting. Otherwise, just staring at like David M drove me nuts. Okay, so for people who just entered, this is probably the last time I'm going to do this. We have like 6 pair of people in a poll. You can like vote who you think they look the most similar. And the people on the left, the 3 pairs on the left, they're all code in place people, and the people on the right are like random people that have nothing to do with code in place. They're just like people I know.
But I think you need to launch the vote again because
Really? Um, can you
I'm
guys
not.
not see the vote?
I mean,
Um,
I don't
y-
see it at the moment, although I'm the host, so I guess I don't get to do that.
right. Well, okay. So
I also don't see. I also don't see the poll.
you don't see the poll? Oh,
No.
okay. Well, okay, I'm gonna close the poll and I will launch it again. Sorry, guys. Okay, let's let's see the poll. I don't know why you don't see the poll, but okay, so let's launch it again. Okay, poll.
I think my computer is stoned.
Or
I
maybe
see.
my
I see only
computers.
results.
Okay,
I couldn't
Computer is
answer because I see
stoned.
only results now.
okay.
Oh,
You see the poll now, right?
yes.
Yes.
Okay, you see the poll now, and then you see the screen share.
Yes.
Okay, I'm just gonna give people 1 minute because we don't want this to be
Do
taken
do
up all
do
of
do
it.
you know who all the people are?
Of course, I know who all the people are. I mean, do you think I just like stalk people randomly on the internet and then take their pictures?
Yes.
No, I mean, I know, in fact, I think I know every
Only
single
one question on this picture. I want to know who the evil Tom Cruise is.
who the evil Tom Cruise?
Yeah, there is like Tom Cruise and there is evil Tom Cruise. I want to know who that guy is.
Um,
It, it's the one that's not the Scientologist?
Wait, do you mean it's the okay? And so you agree he looks like Tom Cruise, right?
Sure.
Yeah.
I selected those two guys. So
Yeah,
neither of
I thought so too. Well, I will tell you guys who all these people are. So okay, well, I'm gonna stop the poll. We have like if you want to vote, feel free to vote. Um, so okay. Anyone who wants to vote has voted. Alex, I think you need to let somebody else in.
uh, yep.
Okay. All right. So I'm going to stop. And the poll looks like this. Um, do you guys all see the poll? The results of the poll?
Yes.
Okay, so let's see who these people are, okay? Um, and so the top vote getters is like pair A and B, and then there's some vote for E. I'm actually surprised that wait, no, D and F got no vote because if it were up to me, I actually think F looks the most similar. But anyways, okay. So who are these people? Okay, so yeah. Okay. So the first one we've seen, this is like Cameron in the Olympic pommel horse guy from the US. And then B is like Bono and Alex. And then C is actually Luke Perry of 90210 fame and Alex. Okay. I mean, I don't think Bono and Luke Perry look anything alike, but I think Alex looks kind of like both of them, depending on I think like age and stuff like
I
that.
don't see anything similar between me and Luke Perry. With all due respect to Luke Perry,
You
I
don't
don't
think so?
think. No, I can see the similarities with Bono to a certain degree. I mean, we're both wearing red glasses, so yeah, that sort of
I
works.
mean, you don't think you have some similarities to Luke Perry? Because like
Sure, a couple of eyes and nose.
no, I
Yeah,
mean, I think like the smirk, and the high cheekbones. Anyways,
Alex is
anyway.
breathing. There we go.
Okay. And so D, E, and F are all like my friends. Okay. Um, And so one of these three is my husband, but I'm not going to tell you who. But suffice to say, they're just like all my friends. And that's that. Okay, and somebody else. Okay, so this is the last time we're gonna do this, and I'm gonna wish my husband a happy anniversary because it's our anniversary this weekend.
Oh,
Um,
really?
Yes.
Congratulations.
Okay. So as many of you know, next week is the last time we're gonna meet. And so that means Alex will get rid of the albatross around his neck very, very soon in just 1 week. And then typically as in Stanford fashion, okay, the last week or two is the toughest. It's called Dead Week. And then usually a very good like teacher or teaching assistant would bring food because students tend to get very stressed. And when people get stressed, you need like glucose to kind of make your brain think. Okay. And so I actually thought long and hard as to like how I could like bring food. Um, and and I couldn't really think of a good way, but what I have posted here, if you guys want to take a screen capture, is actually a Starbucks card, okay, with like the well, not the QR code, but the barcode on the back, as well as the number. I don't actually know if this card is good outside of the US. Um, but you're feel free to like take down the number, take down the barcode, and then buy yourself a drink, bring it to our last meetup next year. Just like don't bring everyone in your family and their uncles and kids because I don't have that much money on this card, okay? But I think it should be enough to buy each of you guys um, a drink of your choice, if you can find a Starbucks, and then if they would accept a Starbucks card from the US. And then also Starbucks now has boba, except their boba is not very good, at least in the US. Okay. And then one last thing, and then I will stop talking. Okay. So I'm gonna do like a social experimentation, okay? Just because I felt like I've actually spent a lot of time learning Python and I don't want to like lose it. So I don't know if anybody on this forum had this particular section leader. He's actually someone who had reached out to me in the context of this Zoom meetup, and then made some of the extra material he had um, some of the extra materials he had made for his own section available. And so I thought, I would do this once just to see if people might be interested, and also to demonstrate it's really not that hard if you guys want to continue meeting, okay, to kind of set something like this up. And so hopefully, once you see how easy it is, other people might volunteer to organize future meetups so that you can maintain your hard acquired Python skills. And so this is Kelly Ford. You can read about his bio here. And to be completely honest, I was not in his section. I don't know what his teaching skills are. But he sounds like a really cool guy because he loves to travel, play the piano, great food, everything I want to do when I retire. And then more importantly, he's a Stanford grad. And so as you guys all know, Stanford people are cool. They can't really talk like David M, through a wall, but they're very cool people. So I think that should be very high endorsement for Kelly. And so the problem that he gave me was I will share this problem, and so you can see what the actual problem he will be coding would be, okay? And so the project is to program this clock, okay? I think all of the skills would be using the first part of code in place. I don't think it really calls on the sophisticated list and dictionary and OOP that we've learned. But if you think you might want to consolidate and review some of the skills, this is the problem that he gave me. And then when we meet, okay, we'll go over that problem. And so the way that tentatively I'm going to work this, okay, is this week and next week, I will send out a Google poll. So Google poll is completely free. And so if anyone is interested in setting up future meetings, you just need a Gmail account. You can set up a Google poll. I will send out the Google poll. You can ignore it if you're not interested in participating. Um, let's see. Okay. So the Google poll looks like this. Okay. Kelly is based in Berlin, and so he has very kindly and very considerately picked times that are amenable to virtually everybody in this session. And so it's not in the middle of the night. Okay. It's actually during daylight hours. And so he gave me about 8 different times in October. I told him I cannot meet prior to October because I just need some downtime to get my life in order. And so if you are interested, okay, when you get this message, please mark all of the times that you think you can make, okay? Please don't just mark one. Please mark every single time that you think you can potentially make. And then we're just going to be democratic about it. We're going to pick the one that most people can make. Okay. And then also, I don't really like to spam people's inboxes. So there is also an option, okay, since our life after code in place is officially going to be over next week, if you no longer want to get any kind of email from me or my sort of alias, Constance Contrary, just mark this box, and then I will take you off of the email list, okay? And then you won't get spammed in the future. And then I've also included a link of this clock sample so that you can look at that further. So I told Kelly that I'm aiming for at least 10 responses, a minimum of 10 responses to make this a go. And so if I don't get 10 responses, I don't think it's like worth Kelly's time or my time to actually do this. And so I would encourage you guys, if you're at all interested, to actually return the poll. And then also, I'm not going to be recording this session just because hopefully in the future I won't be the one hosting it. So I don't want to be committed to have to be there every single time to actually record this. And so this is actually like pretty easy to set up because like Google Forms are free, and all you have to do is to kind of find a person, find a topic. Hopefully somebody would step up and then pick like an OOP topic in the future, because I think I could use more practice on that. And yeah, that's it. Okay, thanks.
Hey, thanks a lot, Vicky. I mean, especially with the Starbucks card. I mean, that's so cool. That's so cool. I hope that people do get to use it. I don't know. I also have no idea whether it's possible to use it outside of the States. We don't have Starbucks here in Armenia, so no way to check for me. But still, even if it works only for those of you who are in the US, it's still a very cool gesture. So, hooray, hooray for Vicky! Please remind me, Vicky, I do not remember, do we have like until 11 a.m. today?
Yes. If
And
I
that's a
can
hard
go a
stop.
little bit over to past 11, I do have to do another talk, but I have until at least 11:15.
Okay, but we'll just try.
But
We'll
Alex,
finish
that's
by
like
11.
3 hours. And you really want to talk for 3 hours,
Do
man?
I want to talk about 3 hours? I don't know.
I
We'll
mean,
see.
no wonder you like David M. Okay. I mean, that
Sure.
guy. Oh my
Sure,
goodness.
that guy just talks and talks and talks. But come on, you have to hand it to him. The guy managed to explain a topic which is not a 2.5 hour topic in that time. Sure, yeah, he speaks quickly. He is, he doesn't go on tangents. He just like a machine goes like. But I thought he got the job done. Although I know that opinions vary, and that's normal. So the thing that we're gonna do today, guys and girls, we are going to finish the previous topic that we discussed with nested structures, because there were I believe we finished with milestone 2 of nested of the bias bars assignment. Please correct me if I'm wrong. So we're probably gonna finish that. We're not going to do the graphics part. We'll just do the coding part, which is the algorithmic part, because I don't see much
No wonder he's
virtue
not.
in doing the graphics. And after that, we're gonna go into object-oriented programming. So let me share my screen. Okay, so do you see my screen? Give me a thumbs up or something, so I know that.
Yep.
Yeah,
Yep.
okay, super, super. So the last thing that we did, if my memory serves me correctly, we did a function which is called add data for word, and what this function did was get a dictionary of word data. If you recall, the word data is split by words, and for each word we have another dictionary which calculates how many times for women and how many times for men we have low ratings, average ratings, and high ratings. And then we have this dictionary. We have a new word a gender and a rating, and we have to add this data into the dictionary. So for instance, initially in the tests, we had an empty dictionary. We got the word good for males at 5.0. So now we have here in the dictionary M, we have at the second index, we have a 1 because we have one mention of this word in a review for men with a high rating. Then, for instance, we have another one, which is also the word good, but for women also with a high rating. For each new word, you have to add 1 to something. And we did this. We checked whether the word was already a key in the dictionary. If it was not, we created a new key with zeros across the board. And then after that, we used, since it's a nested structure, we had a word, then we had as a key, then we had the gender as a key. And then here we had the index, which we took from the rating. It was either 0, 1, or 2, depending on the rating, and added 1 to that specific part. By the way, you are. No, hold on, Vicky. You're saying C was my husband, but do you mean D, E, F?
No. I mean, I was replying to somebody else in the chat. Forget it. Okay. I'm not talking about the C here.
Okay. All right.
Move on.
I'm gonna then privately share with you my thoughts on who your husband is. I've never seen him live, but I have a guess who he is. So, but
Okay.
we'll keep that in private. We'll keep that between us.
No. Who do you think he is?
I think the last one.
No.
No?
No.
Okay, so then I'm wrong. So now let's go to the next function which we need to do, and the next function is called read file. So what we need to do in it, it takes a file name as a parameter, and we need to return a word data dictionary, which will store all the word data from that file. So obviously we need to use the previous functions that we wrote, the one which is add data for word, and let's take a quick look. So the first line of every file contains a set of strings describing the format of the file, and we ignore that. Then we have each line is a single review, which has 3 comma separated values. So the first one is the rating, the second one is the gender, the third one is a string. And the string is basically a number of words separated by spaces. And we need to take each of those words, which are called tokens, and use our add data for word function that we implemented in the previous milestone to add that information to the dictionary. So it says here, do not make any assumptions about the number of lines in data in the file. So we have no idea how many lines the file is going to have. And we can test it using small 1, small 2, small 3, and then run it on the big data set. So the way we are going to do this, first, obviously, since we're going to be reading data from a file, we need to open that file. Judging by this, let me check what's going on in the chat. Okay, all right. I see the husband discussion is like full steam ahead. So let's open the file first. So we're gonna do this with open file name. Remember that the file name is passed to us as a parameter in the function definition. Let's do just because we can UTF-8, because we're not certain that we're gonna get only words. Maybe we'll have some smileys in there like emojis, or I don't know, non-English stuff. So let's do this. We open it as file, and I'm trying to remember, I think we did something to read a file, but was it for, no, I don't think it was for this one. Okay, never mind. Because I remember that we actually did this somewhere where we got rid of the first line, and then we parsed all the rest, but let's do it again. It's not a problem. So since we're told that the first line in the file does not interest us because it does not actually have any information, we're just gonna skip it. The way we're gonna do this is file read line. So read line reads the line, we do not save it anywhere, we just throw it into the trash bin. So for all the remaining lines, we're gonna do for line in file. And then, since theoretically we could come across empty lines, we need to make sure that we're not trying to parse an empty line. Could you guys, I hear some sounds from somewhere like notifications. Can you maybe mute just in case you are? So for each line in a file, we're only going to work with that line if there is a line. So when I print if line, I'm checking that it's not an empty line. So I'm gonna write checking that it's not an empty line. I still can hear someone. Alyssa, I think that's you. Let me mute you. Yeah, there we go. So if there is a line, then we know, at least according to the assignment, that there will be 3 comma separated things in there. The first one will be a rating, the second one will be the gender, and the third one will be the, what's it called, the review. We're gonna get it is do line. We take the line. The first thing I'm gonna do is strip it of any extra, slash ends at the end, so they don't get in there. And then I'm going to split it by comma, because the comma is the delineator or the limiter, which is given to us in the assignment. Then the rating I'm going to turn into from a string, because these are all strings right now. We have 1 string, 2 string, 3 string. So I'm going to turn the rating into a float. I don't need to do anything with gender. And with the review, remember at the moment, the review is a long string of words or tokens separated by spaces. So I need to turn it into a list of words or tokens. I prefer words. So to do that, I'm going to take review and I'm going to use split on it once again. And this time I'm going to split by space. So what I have now is I have a floating point rating, I have a string gender, and I have a list of words, and we need to go through those words one by one and add them to our dictionary that we will need to return as the result. And now that we recall that we need to create a dictionary, let's do that. Let's create a dictionary which is going to be called word data. Initially, it's going to be an empty dictionary. And what I'm going to do now that I have this data, or is it correctly to say these data because it's plural? Now I will go through all the words in this list one by one. So I'm going to go for word in words. And for each word, I'm going to invoke the function, call the function that we created previously. So here it is. I'm going to do this. I have word data, which is our empty dictionary initially. I have the word which I need to add. I have the gender and I have the rating. And basically when I call this function, remember the word that we need gets added to our dictionary. And we do this over and over and over and over again until we run out of words in the first line, then we run out of words in the second line and the third line, and we do this until we read the entire file. So we do it line by line, word by word in every line until we're done. And the last thing we need to do is what? Please remind me after we're done with all of this, what do we need to do at the end? Anyone? Any ideas?
Return.
Exactly. Thank you, Nate. We need to return the result of our hard work because that's what the assignment tells us. Please do not forget to return the dictionary that contains all the word data. Let's see. Let me maybe add some comments here. Just let's first see whether it works. Before I start commenting and patting myself on the back, let's actually see whether this works because it's never guaranteed. Oh, really? So data is actually singular. That's interesting because I also always thought that data is supposedly like datum is supposed to be singular and data is plural, but thank you for the clarification, Richard. Always interested in linguistics. So let's try running our doc tests and see whether, and it seems that we pass all of them. Let me just in case try them separately, although I think they're all run at the same time. So it seems that we managed to finish milestone 3. So once again, this is like our initial data dictionary is empty. Here we discard the first like useless line of the file. And here, I think this is clear. So we split the review, like the entire review into words, or they're called tokens. And for each word or token, we use the function from milestone 2. Milestone 2. So, and that's the way it works, and return the result. So, are there any questions on how this works? And I just made this a bit larger because I remember last time we're actually at about 32. So let me do that. Any questions? Any comments? Any whatever?
I posted a question on the chat, Alex.
Okay, yeah. Let me take a look at the chat. So, okay. So yeah, Leah, you're saying, Alex, I've seen the word token a lot lately because of GPT not being able to process the right answer. How many R's are present? Oh, I remember the story with the word strawberry. Yeah. Yes, they are correlated. They are the same tokens that are discussed here. So token is basically it's not necessarily a word, because you could have a number that would also be sort of a token. You could have a emoji in your review, and an emoji is certainly not a word, but it is a token that we also parse as well. So the word token is like a more generalized concept than word. That's the only reason. I mean, you can probably have different tokens. In some cases, a letter could be a token, etc., etc. But yes, they are correlated. It's not the result of splitting. So it's, I mean, in this particular case, we get tokens from splitting a review. But I mean, there are probably different ways of getting tokens. But in our specific case, yes, we split an entire string, an entire sentence. Maybe it's several sentences, but in our case, we know that there are no punctuation marks in there. And then each of those words becomes a token.
Thank you.
No problem. So the Oxford Dictionary, okay, we're talking about data. Yeah, I think I got it. So that was the question. Okay, good. So shall we then move on to the next one? But I mean, if you still have any questions, please shout out. I will return if necessary. So now we have milestone 4. And milestone 4, I believe, is the most interesting one, because milestone 5 is actually there's not much to do there. And we're not going to go into graphics. So milestone 4 is actually searching for words in our data set. So we're going to implement a function which is called search words. And I believe it's the next one. Yeah, here it is. And what we're planning to do in this one is we're going to sort the data which is stored in our dictionary that we've just created with the previous function. Just 1 second. Okay, Richard, I see your question. You're asking, is there an easy way to ensure that not is always paired with the word following? Understand is you would like to pair not with the next word as a single token. And it depends on what you think is easy or not. I don't think there is an easy way to do it. I mean, you would have to come up with a way to do this. So probably the way you would do this after you split it into tokens, you would go across that list of words, and each time you come across not, you would have sort of to take the not, take the word following it, concatenate them together into, for instance, the index where the not is stored, and then remove the next one. So that does not seem too hard. So I would say that qualifies it as being easy, but you would need to spend like a couple of lines of code to do this. But yes, I think it's quite possible. There's nothing seriously difficult about it. And I understand where you're coming from, because not does not, like represent anything separate from the word that follows it. So yeah, it's quite logical if someone's good to take that token as not good and not as separate not and separate good, because that there's more sense in that. I think they just simplified the assignment for us, but I think it's a good question on your part. So search words. Yeah, let's go back to search words. So we are given, the way it works, we're going to be given a dictionary with all of our data, and we're going to be given a string. And we will need to return a list of all words from our data set that contain the target string. And this search should be insensitive to case. So regardless of whether it's like capital letters or small letters, they should all match. So for instance, here we're given a target string of LE, whether it's small letters or capital letters. They should both match the word lecture, because LE is present in lecture. So the same would be with middle, because it ends with LE. It could be in the center, not just at the beginning, not like at the end, but anywhere. So let's think on how we could do this. We need to do a list of words. Okay, so or it's even here, it's called matching words. So yes, let's do matching words. Initially, this is going to be an empty list. We don't have anything. So what we're going to do after that, we're gonna go across the words in our word data dictionary. So we can, since the words are keys, we can simply write for word in word data. Of course, to make it explicit, we can write this. It's the same result, but why bother when it? So for each word, we will have to compare that word to the target string that we're like doing the comparison with. And the idea is that the target string has to be at least a part of this word, and we will lower that target string before checking. So what we're going to do, we're going to say if target dot lower. So we're making small letters because everything that we have in word data is in small letters according to the assignment. So if the lower version of target is in the word, and we say in, when we do comparisons of strings to strings using the in operator, we're actually checking whether the substring that we have here is part of the string that we have here. So if this substring is actually in the word that we're checking, we need to add that word, like matching words, append word. And we will do this for all words in the dictionary. And after we're done, once again, we will have to return the result. I believe this is it. Yeah, Nate, I'm already doing this. Yeah. So let's actually check. Can we check? We don't have any tests here, but we can try running it and seeing what it would do. What happens if we just run the file? Yeah, it still does the testing. Sorry, so okay, we can run it using the using the terminal. So let's run it using the terminal. Let's go by bias bars data. No, how does it? Okay, we need to give it the data file. So for instance, if we say data small one, for instance, okay, that works. And if we do search, we can actually do search. Our target is going to be like we have best and okay, nothing manual. Okay, let's do like ES from the same data file. Small one txt. Okay, the only thing, let's try it on a larger file because the small one is like too small. Let me see. Is this one larger? Average. Let me just check by the letter E, for instance. Let's see how many words have the letter E in them. And we have average, we have best, which is logical because besides these two words, you only have not, which does not have the word E. So it seems that our function is working. Let's take a look at it once again. So here, create an empty list of words. Like go through all the keys, which are words in our word dictionary. Here we check that the lower, or check whether the lowercase version of the target string is in the word. And here we say, if yes, we add it to the list. We could actually add a separate if statement here to see whether that word is already in the list. And if it's already in the list, we do not add this again. So for instance, we could write if word not in matching words, then added. Because, I mean, if the word repeats itself, I don't think that we're, supposed to have multiples of that word, but let's check just in case that it works like this as well. Yeah, it does. So here we're making sure that the word will have only, each word will only end up once in that list. So are there any questions on this specific search words function? Or like, again, once again, any thoughts, any comments, anything? I'm just checking, looking at now at how they're trying to tell us to test milestones 2, 4. I think we tested these. So for instance, here we can let's do this. Let's do this check to see whether what we have corresponds with what the assignment expects us to have. So we checked the entire full data txt. Remember, full data is a huge file with like thousands of reviews. We're checking for words which have the substring pand in them. And we have here expanded, expand, expanding, mind expanding, pandered, expands, pandering, and pander. So these are all different words. Let's see whether they're similar to what's expected here. Expanded, expand, expanding, mind expanding, pandered, expands, pandering, pander. Yeah, so it seems that we've done what was expected of us for milestone 4. And since I don't see and I don't hear any questions, the final milestone that we're going to do for this one is actually running the provided graphics code and checking that this works in the graphic representation. So we need to open, I believe, just a sec, how do we launch this? Oh, we'll do it like this, like just launch bias bar spy. And so we get this window, which was pre-programmed for us. So this window is done in a library, which is called, I'm not even sure how to correctly pronounce it, TK inter or something similar. So this is not something that I've done. This was pre-programmed, but what we need to check, if we actually go into the search bar below and we start typing words, or like target strings that we need to check and then press enter, you will see that in this window, we get the same result that we got when we launched it in the terminal. So we have the same words, expanded, expand, expanding, etc., which are used to then build graphs in this window. We're not going to be doing graphs today for the simple reason that we have object-oriented programming to cover, and actually drawing the graphs has nothing to do with data analysis. It's simply, figuring out how to use the graphics module, the canvas objects, which we've done in code in place, but it's about calculating locations where you need to draw each column, how to change their colors, etc. While it's an interesting thing to do, it basically has nothing to do with nested data structures anymore. It's just an exercise in mathematics and calculating pixels and stuff like this. So that's why I don't think it's worth going into it, because I spent some time. I actually finished milestone 6. I spent some time doing it. I did not really enjoy it because of all the pixel hunting. And milestone 7, I just said I don't even want to do it. I'm not sure why I'm doing it. Nate, you're saying you're curious if you use TK-Inter in your program or just the other one you mentioned, Pygame. I do not use TK-Inter. Some time ago, I tried using it, getting into it, but since I did not really have a reason to do it, it was just oh, let's see for fun what this does, and I did not really have a reason to get deeply into it. So yeah, I'm not a good person to tell you about TK-Inter. I mean, I know that some of the stuff that we did on Code in Place, working with canvases and stuff like that, it's taken from this library. I know it in full. So I think then if there are no more questions on this part, I think we can say goodbye to nested structures for now and go into object-oriented programming. We have 2 hours and about 10 minutes until preferably to finish. I'm not sure that I'd be able to go through everything that I wanted to, because for today, the things that I wanted to be able to do with object-oriented programming, I actually have a small presentation. I'm not sure it's small or not, but a presentation that should be helpful, especially if you took the time to watch David's lecture and maybe read about some things in other places about object-oriented programming, because of course if you're going into this like an empty slate, it's going to be more difficult because object-oriented programming is not a very easy paradigm to shift into when you're used to procedural programming that we've done up until now. Also, one of the most common questions that is asked by students when they encounter object-oriented programming for this first time is, why do we need to use object-oriented programming? Because we can sort of do the same things using procedural programming and it takes less code. And this is true. And this is a very difficult question to answer when you do not have the experience of writing large amount of code. So if your program is like 20 or 30 lines long, and most of you have not actually written, code that spans like thousands of lines of code. I have not written like many programs that are, in the thousands of lines of code. Like the largest ones probably that I write are maybe, 400, 500, 600 lines of code, but nothing, too. And the simple truth is, if your program is simple, you do not need object-oriented programming. But once your programs get more and more, it suddenly becomes easier to put all of this stuff together in a different paradigm. It becomes easier to, have your data stored in specific objects, which I'm going to talk about right now, instead of all over the place in your code and variables. And it's very hard to explain this theoretically. The only thing I can say, trust me, there are certain reasons for using OOP, and it's good to at least know OOP basics, because many modules and many libraries use OOP as the industry standard, and you would not be able to use them if you do not understand how OOP operates. So that's all I'm going to say, as an answer to why you need OOP when you have simple procedural programming using just functions like we're doing right now, because it's a thankless job and I will probably not be able to answer you fully. So just trust me.
Alex, if it would
Vicky,
help,
yeah, I saw your, yeah, I'm reading your message in the chat. So if you think you're okay with doing this, then, well, let's get to that point, when it's 11 a.m. and we'll see where we are at, and we'll decide from there. Okay.
Well, I don't want you to like have to cut your presentation short just to make that
No, this
short.
this will not affect my presentation. My presentation is gonna end a lot earlier. Obviously, I was thinking of actually writing some like more like not just simple example code like David wrote, but something more like closer to real life, and I'm not sure how much time that would take. So
Yeah, I
that's
mean, you could just like stay on, as long as you want, because
as
we
long
all
as I have
know
people
that
listening to
you
me.
love doing this, and so there's not that much opportunity to do this. Only one more week, so.
All right. Okay. Thank you. I'll bear that in mind. Abhinav, I see you're asking, can I explain decorators? And I'm sort of like going, but will I be able to explain decorators like fully and completely? I can't say that I'm a big user of decorators, though they are in, like of Python. I will do my best. I'm not sure that I will be able to do it like extensively, but let's see. We yeah, we'll do this for the chart program. At least there, I understand what the decorators do. Okay, so let me first go into the presentation that I promised you, and let me know whether you can see the presentation right now on your screen.
Yes.
Okay, cool. So object-oriented programming. The name of this paradigm is like, I don't know, it's 50 years old. I don't know like how long, when, I don't remember when the first object-oriented programming language appeared. Vicky, I see you raise your hand.
No, I was trying to figure out how to lower my hand. Sorry.
Okay, no problem. So these days, when I just look at OOP, you don't even think what it signifies. You sort of have in your head the paradigm itself. But if you think about it, like object-oriented programming means that it's a programming paradigm that has objects at its center. So it's based around objects. And so then the question becomes like, what's an object? We have not discussed objects previously, so this is obviously a new thing, and we need to make sure that we understand what we mean when we say object. So, like I said, object-oriented programming is a programming paradigm that focuses on objects and their interactions with each other. And the reason why this paradigm appeared in the first place is that, people who came up with it said, well, look, like in real life is basically objects interacting with each other. And anything that you can call an object in real life, you could do basically the same in programming. So for instance, right now, I am Alice, I am an object. And I'm sitting in a chair, which is also an object. And this chair is in a room, and I can imagine a room as an object, which is sort of less logical, like, is a room an object or not? But in case of programming, a room is also an object. And this room is situated in an apartment, and this apartment is also an object which has other object rooms, which could have other person objects, other chairs, other furniture. And obviously the apartment is located in a building, so the building is also an object. And this building is located in a city or on a street. The street can also be an object, and the street is in a city, or a city is an object, and a city is in a country is an object, and this country is in a continent, the continent is on a planet, the planet is in a solar system, the solar system is in a galaxy, and so on and so on. And all of these things are basically objects. And these objects interact with each other. So in real life, all of us interact, like all of the objects, this way or that way. So for instance, When I enter a room, this means that there is some interaction between me as an object, like Alex, the object, and the room I'm entering. So I was not in the room and now I'm in the room. Or for instance, with the chair that I'm sitting in, it's also an object. It was empty and then I sat down on it. This is my interaction with an object. And you can come up with a million different examples of how different objects interact with each other. I don't know, you're playing tennis, your tennis racket is an object and the tennis ball is another object. And when you hit one with another, they interact, they change according to certain rules. In our case, those are rules of nature, rules of physics, of how they start behaving differently in the world. So, and basically the idea was that if life is all about objects interacting with each other, maybe it will be easier for people to understand complex programs if these complex programs are also made of objects. Can we, anything that we have in a program, can we turn that into an object and think about our program working as a bunch of objects interacting with each other? And I'm going to go with the game because I'm a fan of games. I'm a fan of old console games. So I'm sure that many of you recognize the screenshot which you see here. It's obviously a screenshot of sort of modernized version of the original Super Mario game back from the late 80s. And my question to you is, when you look at this screenshot, can you give me specific objects that you see on this screenshot? You can write them in the chat. You can do this, with your voice, whichever way is preferable. What are the objects that you see on this screenshot? Okay, so we have Mushroom, obviously. We have the Goomba, which is an enemy. We have Mario himself. That's correct. We have bricks. Excellent. Now, Chiara, I see you're also adding clouds. Yes, clouds are also objects here, though they are probably part of a background object. Still, yes, they are here. Leah, I see you're saying score. Yes, we have score as a separate object here. We can see how many points Mario got. So we have the sky. Yes, the sky, the clouds. Then I see Mika, you added the pipe, because the pipe is also an object in this screenshot. We don't, Chiara, when you say coins, I imagine you mean the number of coins that Mario possesses at the moment. Here, yes, he has 1 coin, so we have that. We have some hills, exactly, Richard, correct. And you also have the surface, which is like the ground. This is important. The ground that Mario is standing on is also an object. And Susanna, you're saying the world itself. The world itself is actually, you are correct. It's also an object which collects all of the other objects in it. So good answer. Nate, I'm not sure when you say, oh, you mean the smile of the smiles of the clouds. Probably not. I would assume, I might be wrong, but I would guess that these are specific sprites of the clouds. They are not separate objects. But you never know. Maybe if the smile has to move separately from the eyes for whatever reason, then they also could be different objects. So good catch. The text, all of the text that we have above, like the status line, is also an object. And Richard, you're saying that we need the background split into multiple objects for parallax scrolling. You are probably correct. I do not remember, but I would guess that probably the clouds and the hills would be 2 different objects which scroll at different speeds in order to produce the parallax effect that you're talking about. Yes. Anything else? There is at least one thing that I see that no one mentioned, though you mentioned most of the things. The shrub, yes, exactly. No, we didn't mention Mario. Of course we did. That was one of the first one. But we also have this shrub here, which is also on the screen. It's also an object. It does not it's purely for aesthetics, so it does not play a role, but it is a separate object because it's on the front. It's on the front of the screen. So let's take a quick look. So we have Mario, we have the Koopa, whatever his name is, the enemy, this guy. We have blocks, and obviously we have different blocks, but they are probably as objects. You know, you have like these blocks, you have these blocks, they are different blocks. We have the power up in the form of a mushroom. We have the pipe, we have the grass, we have the background, which, like I said, probably the sky is separate and the hills are separate. Richard talked about this for parallax effect. And we have some game information on top. We have the points, we have the number of coins collected, we have the current world, we have the time remaining, etc., etc. So this block of information is probably a separate object in itself. Okay, excellent. So we sort of figured out how in a game, I mean, there are different programs, not all programs are games, but in this specific example, we have a game and we sort of start seeing how this game is composed of objects. It comes to us intuitively because we sort of understand what an object is. We understand that a pipe is an object. You don't have to, it's a bunch of green things with black lines, whatever. You're not telling me that, the black line is an object, because that's not an object. We understand that the pipe is an object. So each object, of all these objects, for instance, in the game that we've just discussed, each of those objects, and in general, all objects in object-oriented programming, have their own properties. And these properties describe what state the object is in. So if you take me, for instance, as an object, I have a certain state. I don't know, my level of energy, my location in the world, like my longitude and, whatever, the latitude, and how, far away from how high or low I am in this world. And I don't know how hungry I am, how thirsty I am, I sick or am I healthy, etc., etc. So these are all things that describe my state. And the second thing that objects have in object-oriented programming is behavior. Behavior is what actions the object can perform. So once again, if you look at me, I can sit, I can stand, I can talk, I can shout, I can sing, I can lie down and go to sleep, I can jump, whatever. I mean, there are many different things which I can do. And those are my behaviors, my possible behaviors or actions that I can perform. And obviously, these actions affect my state. So for instance, if I'm hungry, my state says I'm hungry and I eat, so I perform an action, the action of eating. And by the way, I'm eating another object, for instance, an object like a pizza. And this pizza has a certain number of calories. So the calories of that pizza is the state of that pizza. Maybe the small pizza has like less calories and the big pizza has more calories. And when I eat it, those calories go into my object. So they increase or decrease my hunger. And as you can see, we already have interactions between objects affecting each other in terms of state through the actions that these objects have. Like a sim, yes. We've all seen The Matrix, so we all know that our life is actually simulation. So yes, you're basically simulating something which has objects with states and objects with behavior, with actions that those objects can take. So my next question, so in object-oriented programming, the properties, the sort of fancy word for properties is attributes, or sometimes they're called instance variables. And I mean, these two things mean the same. I prefer attributes just because it's shorter. But if you hear instance variables, it's the same thing. And we know the word variables. The question becomes like, what's an instance? An instance is a synonym for object. So I am an instance, or the chair I'm sitting in is an instance, but we'll come to that a bit later when we talk about classes. So for now, the properties are called either attributes or instance variables, and the actions is already a word we know, methods. We've been working with methods since the first week of Code in Place, because remember, we had Carol, and Carol was actually an object. We didn't know about it back then, but Carol was an object. And Carol had some attributes. So for instance, Carol's location in the game world, Carol like number of beepers, etc., etc. And Carol had a number of methods that we could use to change Carol's state in the game world. So remember, Carol could move, Carol could turn left, Carol could pick up a beeper, and Carol could put down a beeper. Those were 4 methods, the only 4 methods that Carol possessed initially. And that's basically a description of Carol as an object, Carol's attributes and Carol's methods. But since we're talking about Mario, let me take a quick look in the chat. Okay, Richard. So that's interesting. So in your case, you have a different perception of what an object is. Yeah. So then in your case, I would not be able to say like, we naturally pick up objects the way they are. So for you, it's obviously different. And I mean, then you'll have to look at this differently, but I mean, you've been living in this world, which for us mortals is like a collection of objects. So you've been living in it, and you find ways to cope with it. So I'm sure you would be able to look at this because you've been doing this for your entire life. How do you do what you do with that? Your work is all about visualization.
Well, ignore that. That has nothing to do with what you're talking about.
Oh, okay. So object is an instance of a class, so attributes and class variables are the same. Not specifically class variables, but instance variables, because class variables and instance variables are different things. We'll maybe touch upon class variables later if we have the time. So will you explain later why attributes and instance variables are the same thing? Terminology in OOP can be confusing. I think the reason for this is that multiple people came up with multiple terminology when creating different programming languages. So, I mean, if I create my own programming languages, I can call, instead of attributes, I can call them, I don't know, properties. And there is no way to make all the people in the world name the same things, use the same terminology for them. So I believe the reason for this is that different people at different times use different words to describe the same thing. I mean, that's why in any language in the world, you have synonyms. You basically have different words to describe the same stuff. Why? Because, terminology in real life can also be confusing. Not sure whether, Nate, that helps, but. No, you're saying, I see, Vicky, you're saying that they're not the same. No, okay. Attributes are not actions or verbs. Yes. Methods are actions or verbs. So attributes are state, describe state. Methods describe actions. Yeah. So class variables are different. That's true. Instance variables. Okay. So now the question that I have for you once again, we are looking at Mario, specifically at the object of Mario. So we're disregarding the other objects which are right now at the scene. And my question is, what important properties or attributes does Mario have? And when I say important, I mean important to the game. So the question, I don't care that he has a red hat, because the color of his hat, or the size of his nose, however humongous his nose is compared to the size of his head, it does not play any role in the game. So my question is, what are the important properties that actually matter when we talk about, objects in the game world. And this is not easy. This is more difficult than the previous question that we had. So Priscilla, you're saying location. This is important because, yeah, basically location is his coordinates in the game world. Where exactly is he located? Since this is a 2D game, his location will probably be a list of two coordinates, the x coordinate and the y coordinate. Though it can be done differently, but yes, good catch. Location is important. When you say height, Vicky, I believe you mean his size, because size can be different. He can be small, he can eat the mushroom and become large, so we do need to take this into account, correct? Movement, I'm not sure what you mean by movement, Mika, because movement is not a property. I mean, I don't have movement as a property. I have movement as a method, so I can move. But maybe you meant something different, so I would ask to clarify what you mean by movement. Moving forward, like,
no, I meant jumping, but I guess that is also a
yeah,
property.
we'll get to that a bit later, because remember, there are attributes which talk about state, and we have methods which are about actions that you can take. And at the moment, we're talking about state. So what describes Mario as an object? So this the same comment applies. Carolina, you said moves forward. That is also not a state description. That is a method. Weight. I don't think there is a weight in the game, in the sense that the game doesn't check whether he's heavy or light.
Well, you could get like a big, huge Mario if he like eats some mushroom.
I do not think so, at least not in the basic game. I have not played all the games of Mario, so I don't know. But in the initial game, you only had two sizes. You had like the small one, like we have here on the screen, and the large one after he eats the mushroom. That was all.
Right. I mean, that's weight, right? Because he becomes.
It's size or weight. I think size is more important, because size shows you how big or small he is on the screen, and that's important when interacting with other objects like enemies and bricks. But his weight, I don't think he even has a weight. I mean, I doubt that there is an attribute in Mario which says, like, right now Mario is like a 20, or I don't know, like 150.
How about the fact that he has limbs, arms, and like legs? Because you would need those limbs to execute your methods later. Because
Sure.
he doesn't have legs, he can't jump.
Sure, but I mean, in reality, Mario is just a sprite. So it's just an image on the screen. If you remove legs from that sprite, that would not change the way the game works. So in terms of logic, of course, yes, he would need his legs and arms to do stuff. The game, the absence or presence of arms and legs and limbs in general is not important, because he is, in reality, if you strip away the picture, he is probably like a square on the screen that does things, and that then you paste a picture on top of that square. But I have from Adina, this is crucial, this is important. We have velocity. This is important because velocity is a combination actually of speed and direction. So at any point in time, we need to know which direction Mario is moving and at what speed Mario is moving in order for the game to work. Clothing, headgear, I don't think have any effect. These are superficial. Gravity effect, I don't think that the gravity effect would actually be an attribute of Mario. The gravity effect would be an attribute of the world as an object in which Mario exists, because gravity would affect everything. Gravity would affect the mushroom, gravity would affect the Koopa, so it's probably different. Colors would probably be secondary in the sense, I mean, do you remember when Mario changes colors? What are the reasons for Mario to change his colors?
Don't remember.
Because in the original, he could either be red or white. When does he become white?
Don't remember.
Too many young people here. You don't remember the original Mario. He becomes white when he takes a flower and starts throwing fireballs. So the color would be a secondary attribute to his current power state, because he could either be small or large with a mushroom, or fireball spitting Mario if he ate the fire flower. And then in one case he's red colored, in the other case he's white colored. Size, we already said that, yes. Priscilla, you actually, yes, you have a current action state, sitting, running, or jumping, because these are three separate states in which Mario can exist. And I actually forgot about this, so good for you. This is important. If you press down, he actually sits, and that's one state. If he's standing, that's another state. If he's moving, that's a third state. And if he's jumping, it's a fourth state. So different laws apply to these states. Mustache, I like mustache, but I don't think it has any effect on the game itself. Coordinates, yeah, we already talked about coordinates. That was the first one that I think Priscilla said, like location. Location is coordinates. It's very important. Level change, not sure what you mean by level change, but maybe the current level. That would probably be an attribute of the game world. Cuteness, ah, that's nice. But let's see whether the things that you wrote down correspond with what I came up with. And I understand right now that I did not come up with everything, but coordinates in the game world, you said that, excellent. Speed, we talked about velocity. So velocity is speed and direction, but it's also important to have acceleration, because speed and acceleration are different. Speed is like the current velocity that you're moving in. Acceleration is the delta of your velocity, if you are speeding up or slowing down. So you need to, remember both those things, both horizontal and vertical. So size, we did discuss. He could be small or large. Fireball power, I talked about that, whether he's either shooting fireballs or not shooting fireballs. You could say number of lives. Number of lives could be his attribute, because it's logical how many lives Mario has. Like at the moment, for instance, like he has at the beginning of the game, he has 3. Then if he touches an enemy, he loses a life, etc., etc. Number of coins gathered is sort of tied to Mario, not necessarily, but you know how many coins he has in his pocket. And the image sprite itself. So which image we're using to represent Mario at this specific instance. Because if he grows large, we would need another image sprite. If he gains the fireball power, we'll need another image sprite. If he sits down, and this is something that I did not take into account, but Priscilla wrote, different stances, like sitting Mario, jumping Mario, moving Mario. These are all different image sprites, and we need to change them depending on the current situation. Why is velocity an attribute and not a behavior? Because velocity is a number that describes your state. So a car moving at 60 miles per hour, the speed 60 miles per hour is the current state of the car. It's not a behavior. Changing your speed, for instance, accelerating or decelerating or braking, those are behaviors that impact the attribute of speed or velocity of, whichever way you want to call it. I hope that makes sense, Nate. So we talked about attributes. Now let's talk about actions or methods. We already touched upon some of them, but if we go back to the game, what are the important actions that Mario can perform? And once again, when I say important, I mean actions that impact the game itself. Like I'm sure Mario can talk, but talking Mario does not impact the game process in any way. Nate, acceleration, when I say acceleration, I mean the rate of acceleration and not the process of accelerating. Those are two different things. because any body that's located, in our physical world has a current speed and has a current acceleration. These are two different states. You could be, for instance, currently at speed 0, but if at this instant I'm pushing you in the back, you're getting some acceleration from me. Or you could have a very high speed but have 0 acceleration, meaning that you're traveling at a constant speed. So those are two different attributes. And obviously you have actions or methods which impact those attributes, but those are different. This is good. Yeah, Adina, what Adina is saying, like attributes as things that you have, and behaviors are things that you can do. So this is a good explanation in layman's terms. What you have is attributes. What you do or can do are behaviors or method. So we have from Mika, we have the methods that Mario can perform. Obviously, we have run, we have jump, we have, as it turns out, duck. I forgot about that one, but we do have duck. We have throw fireballs. So these are really the main functions, the main methods that Mario has. There is one more, and it pertains to the discussion we had with Nate right now. Can he slide? Slide is a combination of jumping and running. So, or mean skid, if you mean skid to a stop, there is no action per se. If you stop running, then you stop. So it's the absence of running. But one of the things that you can actually do in addition to the things we already discussed is accelerate. If you the B button, I think, then he starts running faster. So you have move, you have accelerate, you have jump, you have shoot fireballs, and the fifth one, which I did not include, that's on me. I will include it here now. I will say duck. I mean, better late than never. And these are methods that the Mario character, the Mario object has. So obviously when he moves, this changes his coordinates. So the movement method affects his coordinate attributes. The acceleration method affects the speed attribute. So when you are accelerating, your speed increases to a certain degree. There is an end. You can't run faster than a certain point. When you decelerate, so for instance, you stop moving, so your speed drops back to 0. Jump obviously affects your coordinates in the game world. Shoot fireballs obviously creates fireballs which are objects in themselves. So each fireball that Mario fires is a separate object. And when that object comes in contact with certain enemy objects, those enemy objects are destroyed together with that fireball object. And you can duck. Duck changes your state in the sense your stance. You're either upright or ducking. So accelerate is both a method and a state. It could be. It could be both a method and a state. So as a state, it would be a noun. So Mario's current acceleration is like this. There is a specific number. And then you would have an accelerate method, which would increase this attribute. You would probably then have a decelerate method, which lowers that attribute, or you could have, accelerate, which works both with positive and negative numbers. So positive acceleration is acceleration, negative acceleration is actually deceleration. And that would be your design decision on how to implement this specific method. So now let's talk about objects interacting with each other. Because at the moment we're looking at one specific object, one specific Mario, which had his attributes, which had his methods. But what would happen in your opinion when Mario's top coordinates, so we have like Mario is a block in the game world. He has like a top coordinate, a bottom coordinate, left coordinate, right coordinate. What happens with his top coordinate, basically his head, intersects with the bottom coordinate of a block. So we have a block like a brick or maybe one of those blocks that gives you a power-up, what would happen when those two objects intersect in terms of coordinates? Pain. I like pain. Certainly there would be, we could have actually, an attribute pain, like the pain threshold, not the threshold, but the actual level of pain that Mario is experiencing at the moment, and you hit your head too much, you would actually die, but that's not what happens in the game, unfortunately. Collision, exactly, but my question is, how would this change the attributes of different objects that are in the game world? Because obviously we'll have a collision. That's the definition of intersecting of two objects. But what would be the changes in object attributes for this? And when I say object, I mean Mario as an object, and I also mean block as an object. So what would change in Mario's attributes, and what would change in block's attributes? So, yeah.
I was just going to say there are two different kind of blocks. So would it be two different attributes?
They would be two different types of objects. So you would probably have simple brick blocks, and you as a separate type of object, and you would have those power-up blocks. So dependent on what type of block we're coming in contact with, we would have obviously different attribute changes. But yes, for instance, for Mario, Nate is pointing this out correctly, Mario's velocity and also Mario's acceleration would change. The reason, because when you hit a block, you go down. So those attributes will change. You do not go through the block. You hit the block, and then the block sort of pushes you back down. So this is important. The block itself either will break, which means that the object will be destroyed. There is no more brick object in the world. Or if this block contains some sort of item, for instance, like Vicky, you're saying a flower or a coin, then the state of the block will change. It will turn from one type of block, like with a question mark, into another type, which is just metal block that you can't break anymore. If it's a coin, then the coin will be added to Mario's attribute. It will increase by 1. If it's a flower, a new flower object will be created above this block, and then Mario would have to go to that object and touch it in order to get the power up. So obviously the block's attribute will change. For instance, it breaks and disappears or produces a power up, and Mario's attributes will change in terms of speed and acceleration. So next question. What happens when Mario's coordinates intersect with the mushroom? What would change for Mario and what would change for the mushroom? So Mario will increase in size, maybe, because it's important. If Mario is already large, then touching a mushroom will not change anything. Maybe give him some points, but it will not increase his size. But basically, yes, if Mario is small and he touches a mushroom, his size attribute increases. Good. If it's a green mushroom, which gives him 1 more life, exactly, you gain 1 more life. So then the life counter, the life attribute increases as well. So that's an option as well. The mushroom will be eaten, but what does that mean for the mushroom object? What does it mean? The mushroom is eaten. What does that mean?
Mushroom will be gone.
It will be gone. It will be destroyed. It will disappear from the world as an object. So it will be deleted. It will be destroyed. Correct. Excellent. So Mario attribute may change, his size, his points, maybe his life count. The mushroom object is destroyed. So what happens if those left or right coordinate intersects with an enemy? So basically, Mario runs into an enemy with his left side or his right side. What happens in this situation? Mario, yes, exactly. So his size can decrease if he becomes small. If he is small, he will actually die, he will lose a life, and then the level will reset to a certain point, a level as an object as well. he will not stop. As far as I remember, Mario does not stop when he runs into an enemy, but we could make it so. It's our design decision as a game designer whether Mario, has to stop, or he just runs through, becomes smaller, runs through the enemy, and he has, like several seconds when he's blinking, he's invincible. This is actually one more attribute that Mario can have, is invincibility. Remember, you can also take the star. I forgot about the star. Star makes you invincible. New behaviors of flight or fight. Not sure what you mean in this specific instance, Nate, by new behaviors or fight or flight. The enemy, as I remember, the enemy in this case, nothing changes for the enemy. So the enemy's state does not changes. In some cases, the enemy turns towards Mario and starts moving in a different direction if it's appropriate. I don't remember the specifics. But basically, yes, Mario's attributes change. Either his size decreases or he loses one life. Usually nothing happens for the enemy, but maybe the direction that the enemy is moving. And the last one, what happens when Mario's bottom coordinate intersects with an enemy, which means that Mario sort of lands on the enemy, on top of the enemy. The enemy is destroyed. The enemy object, probably would play a very short animation of it dying, getting squished or whatever, but then the object is destroyed. It disappears from the game world. What happens to Mario? Actually, no. When you jump on an enemy, you get a boost in velocity and speed. So when you sort of jump onto the enemy and you successfully hit, it pushes you back up. So much like a block pushes you down, an enemy pushes you up when you land on it. So this is a fine detail, but it's important that Mario's attributes, usually speed, acceleration, do change, and the enemy object is destroyed. So I think by this point in time, you sort of start understanding and getting your head wrapped around this concept of a program being a collection of different objects, and these objects interacting with each other through the use of their methods, and these methods changing the attributes of these objects. And there is a scale of objects. Remember, I said like room, apartment, building, street, city, country, world, planet, da 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 da. The same applies to programs. You have Mario. Mario is a part of a game level, which is an object in itself, and you sort of go like, the entire level is an object. Yes, the entire level is an object with its own attributes and its own methods. And then you sort of have the game itself, which is an even larger object because the game contains multiple levels, and those are actual attributes of the game. So you can have objects be attributes of other objects. And now I'm going to talk about another thing which is very important in object-oriented programming. So far, we've been talking about objects, but we have not talked about classes. And a class is a very important concept in OOP. And before we do that, I'm going to do another example with you, because before we talked a very specific object, a very specific Mario on the screen. But for instance, if you take other objects like enemies, like blocks, there are many of them, and they all share the same attributes. They all share the same methods. So right now, we're going to talk about classes, and in object-oriented programming, a class is basically a blueprint for the creation, or I know Vicky loves this word in quotes, like hates this word, instantiation, which means the same thing, to create an object or to instantiate an object, to create an instance of an object. So classes are blueprints of specific objects, which are also called class instances. So instances of a specific class. What do I mean when I say like a blueprint? What's a blueprint? So a class, when you are writing a class, you are basically doing the following. You're saying there is going to be a class of objects. For instance, I'm sitting in a chair right now, but obviously this is not the only chair in the world. There are like huge amounts of chairs. Each chair is an object, but they are all connected by the fact they're of the same class. There is a class called chair, and all chairs, well, most chairs, share attributes and methods. I mean, I understand that sometimes, describing something as a chair goes too far. If you take it modern art, someone says that's a chair, and you sort of go, that's not a chair, that's something crazy. But still, like normal chairs, share a number of attributes and methods. So basically, when you're doing a class, you're saying, okay, I want to use this class as a blueprint for creating certain types of objects. And these objects will have these attributes. So you list the attributes that your objects will have, and they will have these methods. So for instance, going back to Mario, you could say you would have a class of enemy. There are different enemies in the Mario world, but they all share attributes and methods. For instance, attributes like coordinates, like speed, like velocity, regardless of what the enemy is, be it a Koopa or the Goombas or whatever they're called. There are many of them in there. They still share a lot of attributes and methods. And you use a class to describe those. You say, these are the attributes that each object of this class is going to have, and these are the methods that each object of that class should have. And also important, you are usually listing what the attributes of the object are at the moment of the object's creation. So initially there is no object, and then you go like, ta-da, a new object is created. And there are attributes that the object must have at the moment of its creation. So for instance, when an enemy is created in Mario, for instance, it could appear from the right side of the screen. That means that its coordinates are going to be somewhere on the right side, or from the left side of the screen, then they're going to be on the left side. Before that, the object probably did not even exist. It came into existence when the program said, like, this is the time when the object has to be created. So that's what a class is. And each specific object or a class instance stores its own current state. So for instance, if you create 10 enemy objects from a single enemy class, each of these objects will be different. So objects once created, they do not intersect with each other in terms of their current state. So each object, each enemy, for instance, has its own coordinates. Each object has its own speed, each object has its own velocity, acceleration, etc., etc., etc. Once they are created, they are different objects. Much like when you create a chair at a factory, they are all done using the same blueprint, the same plan, but once they are created, they are different objects. Like that chair is that chair, and this chair is this chair, and if I break one chair, that does not mean that the other chair breaks, etc., etc. They become separate entities or separate instances. And an example that I want to show to you, I mean, everyone knows Lego. I mean, even if you have not, for some reason, played with Lego in your lifetime, you know what Lego is. And the Lego shows you how to, build stuff. And for instance, I spent quite some time to find a good picture, but you see a picture here, and on the left side, you have an image of how to put a Lego figurine together. So my question to you is, this image on the yellow background that we have at the left of this picture, is this a class definition, or is this a definition of a specific object? So what I'm saying is that, do these instructions tell you how to put together a specific class of objects, or do these instructions tell you how to put together one specific object? So is it a class or is it a specific object in your opinion? Okay, I see Vicky is saying class, Richard is saying class. Any other thoughts? Do you think this is a class, or do you think this is a specific object? Tatiana, you're thinking this is a specific object. Okay, Susanna, also object. So we have split definitions. And when I'm asking this question, I mean, look at it from the perspective of the person who is actually writing these instructions. So when he's doing these instructions, is he telling you how to put together a class of objects, or is he telling you how to put together a specific object? Any other thoughts, or are there only 4 people right now? Okay, object. Nate is saying class. Beatrice saying class. So, okay, so this is interesting because this is good because we have varying thoughts on the subject. And don't start throwing, bricks or tomatoes at me when I tell you that this is supposed to be a class. And the reason why this is a class, this is a class, is because you're saying whatever figurine you have, put it together this way. So the idea is, take the body with 2 arms, whatever the figure is, it doesn't matter. It doesn't mean that it has to be this specific body. Whatever body you have, take this body, connect 2 legs up its ass, then put on some accessory, put on a head, and put on a cap. But the thing is that you use these instructions, if you have like 20 figurines, if you've ever seen Lego instructions, you will not have usually 20 different instructions how to put your figurines together. You have one picture of how to put any figure together, and you sort of know from this picture that each figure has a body, a pair of legs, maybe some, maybe some accessory, a head, and maybe something to put on the head. Usually, they're usually not bold. They usually have something on top, like a hat or hair or a helmet or what have you. And for this reason, this is like a blueprint. This is a class. This is a blueprint for putting together objects of the Lego figurine class. And then, like more specifically, so this class describes that its objects or instances have the following attributes. So these are basically the attributes of the Lego figurine class. It must have one and only one torso. It cannot have 2 torsos. It cannot have 0 torsos. It has one set of, usually it's 2 legs, though I'm certain there are one-legged Lego figurines somewhere out there, but usually it's a set of 2 legs. It's usually one head. I mean, there are probably some mutants out there, but usually each Lego figurine has one head. Usually it's one head accessory, although I can imagine, without one, a figurine without one, and 0 or usually 1 torso accessory. So it could have this accessory, or maybe it wouldn't have this accessory. So this is Richard. You're saying this is how I see people. So people are basically, a collection of attributes to you. And then on the same picture, we sort of have 2 guys who are already put together, and these are specific objects instances which are built using the Lego figurine class. So they're put together using this same instruction. So someone takes the vest, the legs, the head, the cap. Done. This guy takes the short, the legs, the head, the hat. Done. And you can use this class description to build any number of class instances, aka objects of that type. So these are specific objects because you create this object and you can see it physically. But this is not an object per se. It's just a description of how to build an object. So this is a difference between a class and an object in object-oriented programming. Let me check the chat quickly. Village people, there you go. The picture in yellow is class and the white picture is object. Exactly, Leah. Yes, that's what I'm sort of, that's the way I tried to explain it using this specific example. Yes, so this is a class definition. So this is the description of the class. This is what objects of this class should be constructed like. And these are specific objects built according to this class. And I could have not 2 of them, I could have 6 of them, I could have 100 of them. They would be separate objects, but they would all be of this Lego figurine class. So let's do this one more time. So you see an image on your screen right now. Tell me, what would you call this class? So you see this. This is not a specific object because it doesn't exist. You know, you can see that there is no specific brand. It's obvious that this is done, you know, in some 3D modeling. So this is actually a blueprint. This is not a real car. What would we call this class? Yeah, we could call it car. We could call it automobile. We could call it whatever word you want to use for basically a car. So this class would be class car. And my question to you is, if you were to build a car class, so you would say, I want to build a blueprint to create different kind of car objects. Yeah, I want to build cars in my factory and I need to explain, you know, how to build cars. If you were to, like, you could call it sedan, actually. Chiara, you are correct, because this is a specific, very specific form factor of a car. So in our case, it's a sedan. And so your answer is also absolutely correct. So this is, it's very hard to get an image of a car in general because there is no such thing as a car in general. So I was aiming for car, but your answer is also correct. It could be sedan. But let's stick with car for now. And if I were to ask you, what are the attributes of, you know, cars in general? So what attributes would you have for cars? What attributes would you include in the class description before you actually start building cars? What are the attributes that you have, you know, to have in your mind for cars? 3 or more wheels. So Richard, you could say like number of wheels. So the attribute is the number of wheels, and 3 or more is a specific value. So for instance, number of wheels, yeah, you would probably say that number of wheels. Now the first one that comes to my mind, but sure, why not? It's a good answer. Number of wheels, number of doors, sure. Color, excellent. Power capacity, size, color, yes. Number of seats, lovely. Type of engine. Steering wheel, I'm not sure what you mean by steering wheel, because like, what are the like type of steering wheel? Because hopefully not number of steering wheels, although you can have, I mean, like the cars where you teach, I think they all still have one wheel. You have several sets of pedals, but you have one wheel. Headlights, transmission type, the fuel that it uses, is it like gas, diesel, maybe it's an electric vehicle. Human legs, I love that, yeah. I mean, if we're doing the Flintstones, that would be quite logical. Interior material, electric or gas, number of charger points, whether it's hybrid, steering wheel shape, for instance, why not? The gearbox, etc., etc. So you already see that a car, like in real life, it's a pretty complex object which has a large number of attributes, and they are correct. The ones that I have right now are somewhat different from yours, because I mean, you can go on forever, but there are some important things I'm going to point out. So for instance, the ones I have, you named those, like size, you named like horsepower, you named it differently, but the idea is like the power, like horsepower, the brand, so each car has a brand. You would have like the weight, you could have like the trunk space, how much it takes, you know, the color, and you said number of doors, number of seats, the headlights, whatever. But usually these are attributes that stay with the car forever. or you change them rarely. Of course, you can repaint your car, but in most cases, if your car is white, it will stay white, for the rest of its life, unless you're a fugitive fleeing from justice and you want to, escape, and you need to color your car different color. Or your horsepower will not change, your size will not change, your trunk space will not change, your weight will not change, your brand will not change. But it's important because no one actually mentioned these attributes, although we just discussed Mario, where we had those attributes. Because there are certain attributes to every car, which will change with time. You were brought up with Ladas. Yes. Well, no, actually, I was brought up with Volgas because my dad had a Volga. It's a different car. It's in the Soviet Union, it was a better car than a Lada. So yeah, I'm a Volga boy. So there are also attributes to each car which will constantly change, and this is important. So for instance, you will have speed. And initially, when you create your car object, its speed will probably be 0, because it's strange to create a car that's immediately moving. But this attribute will change with time. Acceleration, the same thing. Are you pressing hard on your gas pedal and your acceleration is up, or are you braking and your acceleration is down? Gas, if it's a gas car or diesel or electric charge, whatever you have, your gas will change. The more you go, the less gas remains. And this is also the car's attribute. Or like mileage, your mileage will increase obviously with each mile that it runs. And this is an important attribute. For instance, if you are selling cars, you're creating a site where you need to tell people what the mileage of the car is, etc., etc. So these are attributes. Some are more static in the sense that they usually don't change. Some are dynamic, that they will change during the lifetime of your object. So now we talked about attributes. The next question is methods. So remember that methods are behaviors. What can you do? What can your car do? I mean, obviously, a car is an inanimate object, so it can't do anything but by itself. But what can you make your car do? What kind of methods do cars have that allow you to change the car's state or the car's attributes? What would those methods, what would those actions be? Shout out in the chat. Accelerate, exactly. Turn. Pickup truck, I'm not sure what you mean by pickup truck. The form factor, that would be an attribute. So a car could be a sedan, could be a pickup truck, could be a convertible, could be a station wagon, whatever you have. That's one of the attributes that a car could have, its form factor. Open the hood, excellent. Open the trunk, open the door. Start and go, change the boot space. That would be interesting. But I mean, if you lower the seats in the back, that could actually change the boot space or the trunk space, depending on the country you're living in. Move, exactly, Leah. So move, actually starting to move would be a method. I'm not sure about crash, by the way, Nate, because crash actually involves the intersection of two objects. And the question would be whether crash is something happens. Well, probably yes. Probably yes. Crashing would probably be a method of the car that would be invoked if the car crosses its coordinates with something which is unyielding, like a stone wall or what have you. And then, yeah, you could have adjust seats, turn on headlights, and obviously turn off headlights, close door, close trunk, close boot, whatever. Some cars can crash on their own. That's true. If you take, Teslas, then yeah, that's the thing that regularly happens. Warm seats. So you get the idea. Like the ones that I have here, like You can accelerate, you can brake, you can turn, you can open, close the trunk, you can open, close the doors, you can fill her up on gas or diesel or charge her up at a charging point, lock, unlock the car, turn on, turn off the headlights. You can do the honk. So there are a huge abundance of methods, like I said, because a car, especially in the real world, is a very complex object. In a game, for instance, you would have a car as a simpler object. It would have probably less attributes and less methods, though would only pertain to what you could actually do in a game. For instance, if you take the infamous, what's it called, Grand Theft Auto. In Grand Theft Auto, I don't think you can change the volume of your boot. You can certainly open and close doors. You can certainly lock and unlock and accelerate and brake and etc. And probably honk and turn on and turn off the headlights. But there are some things which are not important in the game, so you will not have those methods, like warm your seats. That would be nice in a game, but you wouldn't get anything out of warm seats in Grand Theft Auto. So I'm sure the developers did not include that method. So this is another example that I wanted to discuss with you, like take a very specific class, because remember, what we're discussing right now is not a specific object. We're not talking about a specific car. We are talking about cars as a concept in general. And this is a class. This is what a class is. A class is a blueprint that does not exist as a very specific object, but then you can use that class to create very specific objects in innumerable numbers. You have one car class, but you can have a vast number of car objects. And this is probably a good time where we would actually stop with the presentation and go into coding, because now I will talk about the syntax. Before I do that, once again, we discussed objects, we discussed classes and how objects are created from classes. We talked about attributes of objects. We talked about methods of objects. Are there any questions right now that you have, or maybe comments or anything before we actually go into specific code and I show you what the syntax for OOP is? We still have 1 hour remaining, so that's good. No, do the darn syntax. Aye, aye, Captain. Let me do that. So let me leave the presentation then and go. So let me close nested structures and go to OOP. I have already created several files, but let me create a new one, which is going to be called car.py. So I will create a separate file. As you can see right now, I have created a file which is called car. Let me once again increase to about 32 points like this so you can see better. When we're talking about creating objects, we need to first create a class, unless it's an object of a class created by someone else. So we will do this the other way around here. We discussed objects first, classes then. Here we will start with creating a class. And we will do this with a car, but it will be a very simplistic car just for the sake of saving some time. So we will call it car. And the syntax for this is the following. You type the word class. This is a reserved keyword in Python, and then you write the name of your class capitalized. So this is not enforced by Python. You can do something like this, but this is wrong in terms of conventions. So classes in all languages, classes always start with a capital letter. And after that, you can either put a colon, or you can open and close parentheses and put a colon. But usually it's without parentheses. So let's stick to this. And as usual, after a colon, you have 4 spaces of indentation, which means that whatever we write below with this indentation is going to be the description of the class. And the first thing that most classes usually start with is a method that is called init, which is short for initialization. I hate to pronounce that word, initialization. So the way we do it is almost similar to the way that we define a function, because methods are functions in a sense. Each method is a function of a specific class. So the way we do it, we use the def word as usual, and the function that we need to do, well, we don't need to do it, but it's usually done, is written in the following manner. It's 2 underscores, then the word init, and then 2 more underscores. This is a very specific syntax that you have to use when you're creating a class. Python expects that there will be a method which is called specifically like this. There is even a specific name for this. This is called a double underscore, or short, it's called a dunder. So this is a dunder method. And classes have certain dunder methods that Python expects the class to have. And this one is an initialization method, which means that you set up the attributes of the objects of this class upon the creation of this object. So remember, I talked, when you create the first car, it probably has a speed of 0. This is the place where you write this. So also, you probably noticed that in the parentheses, this appeared automatically. I did not type this. The reason is that Python knows that when you're defining a method for a class, the first parameter that's going to be passed into this method, it's going to be the specific object that we're creating. Whenever you see the word self, this might be a bit dense. I mean, this is a place where some people go like, what? I don't understand. Self means the specific object that's created out of this class, and later when that specific object is used, like the methods of that objects are used, self simply means like this object, the current object that we're talking about. This may be a bit difficult, but I hope you will get more comfortable with this concept a bit later. So in every method inside a class, well, not in every, but usually you have to have self as the first parameter, because through self you would be able to talk about a specific object which you're working with. And then you can pass in any number of parameters, like in a normal function, that would help you define your car, your specific object. So let's say, for simplicity's sake, the things that interest me are the car's brand, the car's color, and let's stop at that. What I'm going to do inside this method is I'm going to instantiate the attributes. So I'm going to create the attributes of this specific object of this class whenever this object is created. So the first one will be self.brand. So what I'm saying that this specific object's brand, remember, like this is the syntax for an attribute. When you have the name of some object, then you put a dot operator and the name of the attribute. This is the attribute of the object. And this attribute is going to be equal to this parameter. I could call it differently. I could have done here, for instance, xy, and then say like brand equals x. But in order to clearly show, what is what, I'm going to say, self brand equals brand. And also with the same logic, self color equals color. But then I want to create another attribute, which is going to be speed. And I do not need this to be passed in because, like we agreed, the initial speed will always be 0. So whatever the object I'm creating, the speed of that specific car will always be 0. And for now, let's stop at this. This is a very simple description of a class. So basically what I'm saying, whenever a person tries to create a specific object of the car class, that person must tell me the brand of that car and the color of that car. And then I will create an object which will have a brand equal to this string, which will have a color equal to this string, and which will have a speed equal to 0. So then the question becomes, how do I create an object of this class? I have a very simple class for now. It can't do anything. It does not have any functional methods. But how do I create a specific object? This is very similar to creating a variable. So for instance, let's say, since you remembered Vlada from my Soviet days.
Alex, could I ask a question at this point? Because
Sure.
I'm trying to track very carefully the terminology here. And
Yeah.
I understand what you're saying before, that historically people may use different words to refer to the same thing, but I don't even want to get into that complexity. I just want to understand the basics, the things that people agree on. So in what you have put down on the screen so far in the init,
Yes.
So self, brand, and color are parameters within the parentheses. They also are the list of attributes that are going to be allowed in the class that you're going to define, correct? And then the next line, self.brand equals brand. My understanding was that self.brand is then an instance variable, that you're instantiating the attribute as an instance variable called self.brand. Do I understand that, or am I wrong?
You are absolutely correct. So yes, these are just parameters which are passed into this is also called the constructor method because it constructs a new object. So these are parameters which are passed into it. Whenever I, as a programmer, want to create this object, I say this is what I want it to be named and of this color. And the next 3 lines are actually creating the attributes or the instance variables. Once again, this is the same thing. So we can see here that each car object will have exactly 3 attributes. It will have an attribute brand, it will have an attribute color, and attribute speed. You don't need to call it self brand, self color, and self speed, because self simply addresses the specific object which we're talking about right now. It's not called self.brand. The attribute is called brand. The attribute is called color. The attribute is called speed. It just says that it's the brand, the color, and the speed of that specific object.
And Alex, in the again within the parentheses, you are listing all of the attributes for your class here, and
I'm not listing speed.
Well, speed is but you're not. Okay, so what you're listing in the parentheses are not all of the attributes that can be part of the class?
Sure. It's just the attributes that the class needs to create a specific object.
Okay, but you can't add attributes once you've defined them in the init statement, right? You can change the value of do you understand what I'm asking?
Yes, I understand what you're asking, and the answer is you can add attributes even outside of the init, but the idea is that when you create the object in the beginning, it will have these attributes. So these are the attributes that will appear at the moment of the object's creation. Theoretically, you can later add something to the object which the object did not have before. It's an interesting question of whether that's good practice. I usually try to instantiate all of the attributes of an object at creation and not create something else later. I think it's not very good practice, because then you can run into a problem when you're trying to access an attribute which doesn't exist yet. But Python is very lenient in the sense that it can say, you don't want to, instantiate this at creation. Yeah, you can do it later. Does that answer your question?
Yeah, but just to be really concrete, self.brand, okay, I had labeled that in my understanding as an instance variable set to the attribute brand. Is that
Brand
correct?
is not an attribute. Brand is just a parameter which is passed in from the outside.
I see. So self.brand, is that considered a variable or an attribute?
It's one more time, instance variable and attribute are two words which mean the same thing. They're synonyms.
Okay, thanks.
So these are the instance variables which are set to parameters which are passed from outside when you create an object. And I will show you right now, like it would be easier to talk about this when we have like specific objects created. Can you have nested classes, meaning define a class within a class? These are not called nested classes. This is actually what you would call like parent classes and child classes. So for instance, you could create a parent class which is a car class, and then you would create like subclasses that would be like the car is a parent class, and then you could create subclasses which would differ one from other in something, like you said, like convertible, that would be one, like convertible class, which would be a child class of the car class, and then a pickup truck and the sedan and whatever. And then you could, if there is a reason for it in your specific program, break them down further, into a Porsche class. Like the Porsche will be a subclass of the sports car, and then the BMW would be like a specific BMW would be a subclass of something, etc. But how much you want this tree to grow would depend on what your program is trying to achieve. In some programs that would make sense, in some programs that would be too much. Abhinav, you're
I think
saying
she was asking about nested classes, which you'd very rarely use, if ever, but in that case you just have self, because that refers to the object, so not self.self is invalid.
Then I'm not sure what the question is. Nested class. Oh, okay. I didn't
As
see
in
the
you
second.
can have a
I
class
was
within a class, but not as in
I was reading the first
inheritance.
the first message. Okay. Self.brand. I'm not even sure. I will be honest with you. I have no idea whether. I don't think you can do nested classes like that.
No, you can do nested classes, but you only have self dot and not self.self, because self refers to the object, whichever object it may be.
Okay. I have never done nested classes like that, like class within a class. But then I can say that I'm, a guru of object-oriented programming, so I'm learning things as I go as well. So maybe there is a reason for doing nested classes. I'm not sure what that reason would be. But I mean, that doesn't mean that there is no reason. I just don't know it. Abhinav, you're saying when you create a car object, you need to pass in the brand and the color of your car. That is true. Yes, the answer to that is yes. So let's do that. Let's create, for instance, Richard said Lada. Let's create a Lada object. So this will be a very specific object, and I'm picking a random variable name. So I can call it whatever I want. I could call it like my car, for instance. No, that's not my car. Let's do my dad's car, because I do not want to drive a Lada. So, and now in order to create an object of this class, I need to call that class. So I say car, a capital letter, and then inside parentheses, I need to pass the parameters. And here you see that we have 3 parameters, but the reason that the first one is sort of purple colored is that this parameter will be created and passed automatically by the class. We do not need to pass the self, because at this moment in time, the car class is creating a very specific object, and it's passing this specific object to itself in order to work with it. So we do not need to pass this. We start with these two. So here it sort of seems we need to pass 3 parameters, but in reality we need to pass only 2. The third one here will be done automatically. So my dad's car was actually a Volga. It's like the river Volga. And the color was like light gray. I constantly confuse gray with an A and gray with an E. I don't remember which one is the British version, which one is the American version, but I'll stick with the A. Then, for instance, let's take my car. I think this one, Volga, was 2107. And like my car, the one I have at the moment, let's create a different object. My object would be a Nissan Juke, and the color would be gray metallic. So basically, if we run this program right now, nothing would happen. The program would say, you know, good stuff, the program is done, we managed everything. But in reality, we would create 2 objects. These objects would be created, instantiated in the computer's memory, and will live there until the program ends, much like any other variable. So these are basically variables of a certain class. And if you watched David's lecture, I'm not going to go into this in detail, but the thing is that actually every data type in Python is a class. So you think that an integer is just an integer, but an integer is actually a class. And the way we can check this, we can actually use the type function to see like what's the type of the value 13. And then we'll get the answer class int. And we're sort of, really? So it's a class? Yes, it's a class, which is defined in a similar manner. It's a class which has attributes. It's a class which has methods. We're just not really aware of it. So the same thing I could do, for instance, with a string. And if I run this, you will see that it's also a class of string. So if I, for instance, check my car, what's the class of my car? And I would actually get this. It would say that it's a class main of car, but you can actually see that it's a class of car. Let's actually try printing what we get, because essentially if we print an integer, we get the value of the integer. If we print a string, we get the string. What will we print? What will we get if we print my dad's car and my car? And the thing is that we'll get a very cryptic message because we do not have an inbuilt print function, print method for our class. And if we do not, then there is a default printing behavior for all objects in Python. And it basically says it's an object of a certain class. As you see here, it doesn't say class, it's a like car object at, and then you get a memory address. So this abracadabra is actually a memory address. So by default, if you print any object, you will get that object's memory address, which is not very helpful. I mean, sometimes you're interested in what the address is, but in our case, I would prefer something different. And in order to do this, we're going to create another dunder method, which looks like this. So as you can guess, str stands for string. So we're gonna stringify our object. And as you can see here, self is also automatically passed into this method because we want this method to be able to access the attributes of this specific object to work with them. And what we need to do, we need to return a string that we want to be typed out anytime that we actually want to print this object, an object of this class. So in our case, let's do, this is a self brand. And let's in front, let's place the colors. So this is like a light gray Volga 2107 or a gray metallic Nissan Juke. And we will do something like traveling at self speed. I'm sorry, my dear Americans, but I'm going to use kilometers per hour. I do not know what miles are. Sure, I do know, but yeah. And now, every time we try to print an object of this class, Python checks for the existence of this specific dunder method. So this method has to be called like this. If a class has this method definition, instead of doing the default printing behavior, it will do this. So this is what it will return printed here or here. But let's check, let's see whether it's true. And now you can say, let me put a period at the end. So this is a light gray Volga 2107 traveling at 0 kilometers per hour, which is logical. This is a gray metallic Nissan Juke traveling at 0 kilometers per hour. So you can see that these are two different objects because, well, at least they have different names, they have different colors. For the moment, they have the same speed, but those speeds are not connected. But they are two objects of the same class, so they were built using the same blueprint. Can I also explain the REPR method? Sure. I mean, it won't take that much time. There are actually two dunder methods which are responsible for printing something out. And the difference between str and this one, which I'm not sure, I think it stands for representation. The difference between these two is that this prints sort of a user-friendly string, and this, well, it returns. And this returns a more programmer user string. So this is mostly used for debugging. This is used in final code. So the difference might be, I would say here, for instance, a car object with color, self color, and I don't know, and brand, self brand, at address, and then here I would be able to do, if I'm not mistaken, something like ID self. I think that would work. Let's check. And then let me print not only my car, for instance, but also my car with this dunder method. What's it called? I rarely use it, so I don't remember it. And as you will see, I will have sort of two different representations of the same object. The first one obviously used for users. So a user would want to get information like this, like what's the color of my car in the game, for instance, what the brand, how fast is it traveler. But for instance, when I'm a programmer and I want to, sort of see some of the inside workings, for instance, like the memory address, for some reason I'm checking memory addresses, making sure that it's a different object, not the same object, referencing the address, I can use this function. I don't remember whether there's a different way of printing this out, because like I said, I don't use this dunder method that often. So you probably need to call it explicitly and not like this, and not just my car, but you have to call that method. But then you sort of can get different ways of printing out the same object. I hope this is more or less clear. So Tatiana, no, hold on, I didn't answer all the questions. Vicky, you're asking, do I only need one str per class? Right, yes, it will pertain to all objects of that specific class. So there is only one like dunder str method in a class. The f after the return, I see that answer that it's like for format string. If you have not encountered this before, using an f in front of a string allows you to do these things, to place variables inside the string in a more straightforward manner rather than concatenation or what have you. So this is actually very often used. They are called f strings. I don't know why you would ever want to do this, but if a dunder string is present within the class, it's possible to print the location for some of the objects. Sure, you can whatever. I mean, you can, in this dunder method, you could use any of the attributes that you have to see, where it's located, what's its speed, how much, I don't know, health points it has in an RPG, what weapons it has, like how much money you have, etc., etc. It's your decision as a designer program to include information.
My question is, okay, once you have that dunder string, when you print the object, right? It would just print I guess the attribute of the object. But if you want to get the physical memory location for some, but not for others, since you have that dunder string present, how do you print the memory location for some, but not others?
So once again, so that we're clear, this dunder method is not the only way you can print your object. You can create other methods which you could use. So for instance, let's say your game has like a starship, and at different points in the game you need to give like a short description of your starship, a very dense description of your starship, something else, and you would say, but I only have one dunder method, how do I do this? You would actually have different methods which are not dunder methods. You could actually create a method which would be called, I don't know, print short description. You could have then another method which would be called print long description, and actually call those methods the same way I called this method here. The difference with this method is this is what is going to be printed by default if you simply say print this object. Okay. That's the only difference of this method from any other methods for printing that you might create. You can have like 100 methods for printing your object in different ways. Okay. Does that make sense?
Yeah.
Oh, I'm tiring you. I'm sorry.
I'm just really tired.
Okay, so now we have a couple of methods. One which creates the object, one which prints the objects in a more user-friendly manner. I'm going to get rid of this one. But now let's create something which actually changes the attributes of the object. So for instance, let's create a method which will allow our car to increase its speed, because right now it's a dead car. It can't move. We don't have any methods to actually move the car. So let's create a method which would be called it's not physically correct, but let's call it accelerate for simplicity's sake. And this method will not only take self, which it does by default, but it will also take the speed increase, which we want to, to perform. And this will be a very simple method. What it will do is take our speed, the self speed, which is the attribute, and add the parameter speed that we have here. So it will increase the speed by this amount. And this is like the entire method. There is nothing else to it. So how will we use it? So let's say that we created our two cars. We printed them out. And then I decided to go for a ride. So I'm going to say my car, so the name of the variable. Then I do the dot to call the method, because it's the same syntax as for calling methods like string methods, list methods, etc., etc. It's called accelerate, And it takes one parameter, which is speed. You can even see that PyCharm is helping me out. Do you mean speed? Do you need speed? Yes, I do. I want to go like at 60 kilometers per hour. And if after that I print my car again, we will see that the speed of the car changed. So now my car is traveling at 60 kilometers per hour instead of 0 when it was stationary, while my dad's car is still stationary. This change did not affect my dad's car in any way. It's still at 0 for the simple reason that these are two separate cars. So when I'm affecting one car, it does not affect any other car objects just because it's the same class. The class is the same, but now the objects are different and they're not interconnected in any way. Unless, like Richard proposed, there is some quantum entanglement between them that we're not aware of. But then the question is goes like, but what if I say like 1,000,000 miles per hour? What would it go at 1,000,000 miles per hour? And you sort of go, well, no, because cars usually have a top speed. And then you go, okay, that would be an interesting new parameter. Attribute. Let's give it another one, which is called top speed. And now when we're creating these two objects, we need to add another value. In this case, if, let's say it's going to be an integer. I have no idea what the top speed of the Volga was, but let's say it's like 120. It's an old car. And my current one, I think, well, the fastest I drove it was 160. Like the speedometer has more, but I don't think that works. And now we can actually use this accelerate method to make sure that the car does not go over that top speed. We could add the speed and then say if our current speed is now higher than the top speed, we set it to that top speed. We cannot go faster than the speed of light, if you know what I mean. And now, let's say first I'm traveling at 60 miles per hour, nothing changed because I can. But then let's say I want to accelerate by 200. And it does not accelerate to 260 because I have some error checking in this method. It checks whether I actually went past the top speed of my car, and if I did, it says like, you can't do that. That's not the way physics work. And we could do the same. For instance, if we take another method, which we'll call decelerate, is that the way you decelerate? No, probably 1C, yeah. And then there's also going to be by how much I want to decelerate. And obviously the logic is going to be similar. I'm just going to be subtracting the speed, so I'm braking. And here I will also have a memory check. I will say if after this self speed is less than 0, I'm sort of going, no, I cannot have negative speed. Of course, I could go in reverse. That is sort of like negative speed, but let's say that this is velocity. Velocity cannot be negative. So I will say in this case that speed will equal 0. I cannot go slower than 0. So for instance, if here I hit the brakes, I first will decelerate by, I don't know, like 100. I was going 160, and now I should be going back at 60. There you go. So I have decelerated by the speed of 100 per hour. And if I do the same again, sort of the logic could be that I would be at minus 40, but I will not. I will be back at 0 because in my method here, I'm doing the checking. I'm making sure that I do not push some boundary. So this is important because inside your methods, you can build in certain logic that would not allow you to break certain rules that you want to be present in your game or in your program. For instance, I don't know, if you don't want Mario to ever go beyond the left side of your screen, you would always check that Mario's coordinates are never, like the x coordinate is never less than 0. So 0 is the smallest coordinate that Mario could have, like etc. etc. So this is a very basic example of the car class. Obviously, there are a lot more things to a car than it's just brand color and its speed. But this is to show you a specific example of syntax for creating a class and then instantiating objects of that class with certain parameters, and then using methods from that class to, for instance, print out an object or change the attributes of that object according to certain rules that you as a programmer can set in place. Because with this car, we could go on and on, making a very complex class, but I don't think there is a reason to do that right now. So if you have any questions or comments at this time, please do ask them, write them in the chat. I see Nate here saying, what if you made top speed a constant? How would that change anything? What do you mean? Do you mean a constant for every car?
Yeah, what if you said top speed equals 140? Okay.
And so you're saying that this would be the same for any car?
Yeah, in a way, I'm trying to get an analogy to global variables that we've used before. And
Sure.
I'm asking because it's relevant to the problem we were trying to solve. Because it defines.
Let's say we create a constant which is called top speed, and we say that this top speed is 160. Then you would not need to pass this top speed in here, because that would become sort of useless. We have a constant. And here in acceleration, you will this to the top speed like this. And this would be the same for any car. So this would be, we would not use this. This we would not need. Does this make sense?
Well, again, I'm thinking ahead, and maybe I shouldn't too far, but I'm thinking about the jar problem, which we were supposed to solve. And the way they did it was they did within the parameter, they defined the capacity parameter equal to 12. So that's why I was curious. You did it a little differently by defining it the way we're doing.
Okay, but that's not a constant. The reason why I did differently, that's not a constant. That's what Abhinav wrote. It's the default value. So yeah, let me do the following. Let's say that, for instance, by default, I mean, this does not apply to cars because cars do not have default values, though some cars have like governors built in. You cannot go past the legal speed limit in your country. I mean, that's what I've heard. I don't know. Do you have stuff like that in the States, or did you have like governors in the States?
It's being proposed.
Sorry, one more time.
It's being proposed.
It's being proposed. So let's say we pass that notion. And let's say that our limit is like, 90 kilometers per hour. You cannot go past that. So then we do this. And what this means is if you pass this parameter into the function, into this method, then I will use that parameter. But if you do not pass this parameter, then it will be set at a default of 90. And let's make this, with my dad's car. It's not going to be 120. It's just going to be, the default. And now let me try to accelerate my dad's car, to 160. Not my car, but my dad's car. Dot accelerate 160, and let's see where that takes us. And you will see that I get a here I get a more than self top speed. I need to change this back because I don't have this anymore. One more time. So as you can see now, my dad's car is traveling at 90 because that's the built-in limitation, despite my attempts to, press the pedal to the metal. Because when I created this object, I did not specify the top speed, and this was the value by default. And this is similar. Remember, for instance, when you do print, in print you have optional parameters like end, and the second one is sep, like the separator. They also have variables by default. So for instance, if you would look in the definition of print, you would see that by default, like end equals like this, and sep equals a space. But if you send them in with different parameters, then this is very simplistic, but basically the definition of print has like something like this: print is stuff, and then have these parameters. This is the same. I'm doing the same thing here, saying by default it's going to be 90, otherwise whatever you say. Duck cars in a certain sense.
Alex, I had one more question.
Sure.
So these variables that you instantiate at the beginning, they can be used across all the other methods if you just use the self dot.
Yes. Yes, that is the great thing about object-oriented programming. One of the ideas is that you bundle together all of the information you need about an object in a single entity. And inside this object, all of the methods can access all of the attributes of that object and work with them. And that's the beauty of OOP. Instead of having a bunch of variables which is thrown around your code and you constantly forget, and you have like, if you have 20 objects, you sort of go like, I don't remember which variable is for which object. Here you have everything bundled inside that object, where you have attributes and methods can work with the attributes of that specific object. Yes. The only important thing to do this, you need to have this self-reference. So this is why every method starts with self. Basically, the object is passing itself into this method so that the method can change it inside.
Okay, and then in David's lecture, I think in the init itself, he did like the if, he created some parameters. I want to say like he said if this, then that, whatever. So if that is created right at the beginning, that is also again a default for all the other methods that we use thereafter. So basically, I mean, what I'm trying to understand is whether the init definition is kind of the template, so to speak, and then everything else that follows just basically follows that original template.
The init is this is the first thing that's always done automatically when an object is created. So you could call it a template in a certain sense. You are sort of creating the initial state of the object. So this is what the object is going to be when it's created. And then you can use the other methods to change that state, to change those attributes during the lifetime of your program.
Okay, got it.
Yeah. Okay. Excellent. Any other thoughts, questions on what we discussed here? If you have an object with a missing attribute, will Python throw an error? What do you mean an object? Your object either has an attribute or it doesn't have. Do you mean if you try to access an attribute which doesn't exist?
No. So for example, in the car example, right? Suppose you got your Volga, you got your Nissan, and then you have like a Tesla or something, okay? Then suppose like when you input the Tesla, okay? If you put Tesla, you have like the type of car, but and the color, but you're missing that third attribute, which is the speed. Is Python gonna say like, okay, I'm actually missing an attribute?
But here, as you can see, I have two attributes and it's working because I have this one set by default.
Okay.
If you don't have it set by default, like for instance, like this, I say, for instance, here's a Tesla, but I'm not going to give you a color and there is no default color, then you can also see like the PyCharm is actually, underlining this, because if I run this, I'm going to get a mistake. It says that car init requires a positional argument color,
Right.
but it's not provided.
But for the speed, it's not giving you an error because you gave it a default speed of 0.
Yes. And for instance, if I do color, for instance, by default, all colors should be white, or no, sorry, any color you like as long as it's black. That's the way it goes from Henry Ford. So if I run it like this, now there is no mistake because Elon Musk now has a black Tesla.
I mean, so I guess this is a more of a philosophical comment. And so I guess OOP is actually not that flexible, because, you need the exact number of attribute for each object you create. And so if you're dealing with an object where sometimes you have a missing attribute, this isn't like the best, I guess, platform to work with that,
But
right?
what would be the best? What would be your preferred behavior if someone gives you an incomplete description of your object?
I mean, I don't know, because, well, the reason I bring this up is because in data science, there's a very common package that's used, either called Seurat, that's R-based, or Python, that's called ScanPy. And then the like central platform of this package is either a ScanPy object or a Seurat object. Okay. And I don't actually know what's in the object. Now that I have a better understanding what object is, I might actually go back and look to see what's in that object. But I know that object takes like 20 to 30 different things. Okay.
Sure.
I think central to that object is actually either a data frame or matrices, but there are other things. And then I know most of the time we don't have an answer to every single one of those attributes. And so I'm just curious, like how the program actually deals with that.
Like this. For whatever parameter is missing, you get an automatic none. And that's the value that's stored for that parameter, and that signifies that that parameter was missing.
Okay, which means you give it like a pre-specified value, and then if you give it something else, it will overwrite it. Okay.
Exactly. So you could call this whatever. You don't have to call it none. You can call it like a string NA, which would mean not available, or, I mean, once again, it's your decision as a designer of the program to name it whatever you want to name it. But that's where these default values come into play. You can do a default value for every property, but if you don't, then that means that you need to provide that information. But it's like in this specific case, the reason is like, what's a car without a brand? There is no generic brand. There is a generic color. You could go like color by default is black, the top speed by default, but default brand. So then I would probably require my program to at least provide a brand. Okay, and we covered that question. Any other questions that you would rather ask right now? Or shall we try the specific assignments that we had and sort of look at that? Let's probably do that. So let me close this one and object-oriented programming. So the first one that we have is a very simple assignment where we need to create a circle object, and we need to create a circle class, which would need to provide us with several methods. It would have one attribute that is the radius of the circle. And so when we construct it, there is only one variable passed in, one parameter passed in, that's the radius of the circle. And there are two methods that we need to create. The first one is get area, so we need to calculate the area using the radius. The second one is get circumference. We need to also do this using the circle's radius. And as you can see, it should return a number which will then be stringified and printed in the test code that we have. We have some test code here, and we're going to run it by importing circle from circle, import circle. Yeah. So hold on 1 second, do the assignment. Yes, let's do that. So we need to create a class which is called circle. So let's do this together. What do I need to write to create a class which is called circle? What's the syntax?
You need class circle.
Yeah. What do I need to do then?
And then I think you need a colon.
Yes, I do. All right, so we already have the class sorta created. So what's the first method that we need to create?
You need the dunder int.
Exactly, so that's the first one we do. And the self is put in there automatically. Do we need to get any other parameter when we're creating our circle?
Radius.
Give it
We
either
need the radius.
or diameter.
Yeah, well, in our case, if I remember correctly, it's a radius. So we need to take what's given because otherwise we'd get wrong results. Okay. What do I need to write inside the method?
You need the self. You need to whatever that word that
Instantiate.
M always uses that makes him sound so smart. Like,
Oh, yes.
I hate that.
Vicky, instantiate. Do I sound smart?
I think you should like try to go get his job. I mean,
Right. I can
I mean,
imagine.
you would
Like
fit.
Alex goes. It's like, remember that cartoon? It's an old cartoon which was called Fievel Goes West.
Oh yeah.
We could do like Alex Goes West.
I mean, I could see you fit right in at Harvard. Okay.
Right.
Like,
Just because I can use the word instantiate.
yes, and the accent, and all you have to do is get yourself a bow tie. Fit right in.
I think I can do that. Okay, but back to our code. So what do we need to write here?
You need that whatever self dot blah 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 to like is
More
I still
specifically.
can't say the word to like create that term.
You can use the word create, I don't mind.
Yes.
So then I say, what is blah, blah, blah? So self dot.
Self dot radius
Yeah.
equals radius.
Okay, works for me. Anything else we need to do in the initializer, in the constructor, or that's enough?
I don't think you need anything else.
I don't need anything else, that's true. Okay, so then we need to create a couple of methods. The first method is going to be called getArea. So we do like getArea. It's going to automatically add self to the parameter list. Do we need any other parameters here? Do we need anything else to?
I don't know if you need to feed it radius in here.
But we
You don't.
have access to radius through the self.
Okay. Well, if you have access to radius through self, and then I don't think you need anything. Do you need to give it pi?
Well, I
No,
know
you
pi.
don't. But you have to import math.
Okay.
We could do that. Yes, I don't remember actually in the here does it.
Right.
It
It
uses
did
math.
say import math.
Okay, so let's do
If
it.
you import math, I don't think you need it, but if you don't import it, you probably need to give it pi.
But no, then you can simply use the pi number inside the. Yeah. Okay, so what do I write here?
You want to write an equation, a function, like area is equal to pi times radius squared.
But do I write it like this?
Do you want like self dot radius?
Of course I do.
Wait, can you explain why you want self dot radius? I forget.
Because you are taking the specific attribute of this specific circle.
Well, but you're defining self dot radius equals radius, right? And so shouldn't radius be sufficient?
No, because the get area function does not know what radius is.
So Vicky, that's why I was asking the question earlier, because I like to think of self dot radius as an instance variable. So
It
then that
is.
makes what
It is.
we're doing now more meaningful.
Well, I mean, isn't self dot radius an instance variable? I
It
think it's,
is.
yeah,
It is.
yeah.
Yeah, but radius isn't. Radius
Radius
is
is
what
the
you passed in.
parameter.
Oh, okay. Radius is a parameter that you feed in to define
Yeah,
self dot radius.
exactly. And then as soon as this method stops working,
Got it.
radius disappears. Bye-bye.
So quick unrelated question. Okay, if you're like looking at the memory of the computer, is radius and self dot radius both like pointing to the same place in the memory?
At a certain point in time, they could be, sure, because if it's an integer, they could be pointing at the same memory location, but you can't be sure. We could check. I mean, it's not hard to check. We could right here do print self radius and print radius, and you would actually see whether they're pointing to the same location or not, but it's not guaranteed because it's not necessary strictly.
Okay. Okay.
What's missing in this function?
You
Because
have to
this
set
method.
it to something.
Return.
Sorry,
And
You have to
return it.
set it to something.
we need to return this.
Yeah.
Okay, so the next one, as I remember correctly, is get no, this is a word I hate, circumference, right?
Wait, Alex, for the get area, you don't have to set it to a variable and then return the variable first.
There is no need for that. It's an extra step. You could, but there is no need for that.
So
I mean, you could do something like this.
okay. Just so I understand, right? Initially from your class block, okay, you're giving it radius as an attribute, and then you're using that attribute to define the self dot radius, which is an instance or a variable, right? And then in your method, which is that get area block, okay, you are calling or I guess pulling in that instance variable like self dot radius to calculate the area, right?
Yeah. Yes.
Cool. Okay.
And this is like the difference is because here area is just a simple variable which will disappear as soon as this function stops working, as soon as we hit the return statement. You could ask me, but could we actually do an instance variable which would store the area of the circle? And the answer is yes. But then the question is, do we need to or not? And once again, this is a design decision. Because what we could have done something like this, like self area equals this, and self circumference equals something else. But then the question is, do we actually want to store this additional information, or would it be enough for us to just have a method which calculates on the fly each time when the user asks for this? And in our case, I don't see a reason to create a separate instance variable.
If you do an instance variable, right? Like every time you feed it a different radius, it would change, right?
But you cannot feed it a different radius every time, because you feed the radius once when you create the circle.
No, but
if you do different circle objects,
right.
then obviously each circle
What I
object
mean
will have
is
its
like
different.
if then you create different objects with different radius, that self dot area
It
in
would
the
be different
self-add
for
radius?
each one.
Okay, all right.
Yeah, because it would be based on this specific radius when we create it.
Got it. Okay.
Okay, so with the circumference, what do we need to return here to get the circumference? Anyone remember the formula?
2 pi r.
2 pi
2 pi r.
radius.
Yeah. But of course, self-radius, not simply radius. And I think if we run this test now, we should be getting a result. So this is, by the way, no, I think I'm printing wrong.
You need
right?
to print ID.
Yeah, thanks. I missed that.
And maybe hex if you want it to show the same way and not just numbers.
Sorry?
And if you want to use hex, like hex
It doesn't
ID
matter.
to show instead of just
we'll
numbers.
see whether it's the same address or different address if it's different numbers. So I don't really care whether it's hex or not, but as you can see here, the numbers are the same, so that means it's the same address. So both those variables are pointing at the same location in the memory, to answer your question. And here we're getting the result we're supposed to be getting, but let's, for instance, try doing it with a different one. Let's do it with a 10. And now, as you can see, we're getting different results because now we have a different circle with a different radius, and obviously the object is also different, and the results of calling those methods is also different. So how clear is it with this? Any questions on this specific assignment and how it's done? I guess not, but if any pop up, let me know. Vicky, right now it's 11:06 your time, so does that mean that you have to go, but you can sort of leave us to continue discussing the jar?
I think she's on the phone and she's muted.
Oh, okay, but I think that's what Vicky told us, because I would want to finish the jar today, because I was talking about, maybe writing some more real life code, but obviously we're not going to be able to cover it today. So let's talk after we're done with jar on, what we could do. So let's close for now car. We don't need the circle test. We don't need the circle. Let's go to jar. So in our case with jar, we would need to write our own code to test it. We don't have any, automatic testing code for this one. Let's remind ourselves of what we need to do. We need to write a jar class. So this class will represent a cookie jar, which would have a number of methods. So the first one is obviously going to be the init method, which will initialize it with the given capacity. So by default, the capacity is going to be 12, but if we input a different capacity, it has to be a different capacity, which will represent the maximum number of cookies that will fit in there. Also, if the capacity is, it should be a non-negative int, though this is strange. I mean, like a capacity of 0 does not seem like a cookie jar. So I would actually go for positive integers. It has to be a positive integer. Otherwise, our init method should raise the value error. And we'll talk a bit about errors in this specific assignment, but because I did not touch on them before, they are not like part of OOP, but it will help us. This is an interesting thing. So the second method should print in a user-friendly fashion our object. And here we're told that we should print like a number of cookies in a row, where this number is obviously the number of them in the jar. Deposit is putting a number of cookies in the jar, but if putting this number would exceed the jar's capacity, we should get a value error. And withdraw is the same. We're taking a number of cookies from the jar, and if we're trying to take more than there are actually in the jar, this should also raise a value error. The capacity, we'll talk about this. We'll talk about these decorators. Will return the cookie jar's capacity, and size, another property, should return the number of cookies which are currently in the cookie jar. Originally, it will always be 0, but then we'll have to change this. So,
Alex, could I ask
yep.
you questions at the beginning? So I'm sure you're going to go into it, but at this point, given what the way I heard, the way I understood what David was saying, when he talked about decorators and talked about at property, okay, the only way he used it in his example was when he used private instance variables, okay? And that'll be a decision to be made. But when I saw this starter code, I got confused because I also talked to ChatGPT and I found out that at property doesn't have to only be used with private instance variables. And so I just got all confused about all of that. So if you could clarify that going forward, that would be great.
I'm not sure I would be able to actually clarify it because I do not use decorators that much. And I mean, I understand the reason for using them in this specific, like, Python case, like why they're being used. But when you say that they could be used for something different,
No. My question had to do with, I again, given that I'm a beginner on all this, trying to understand it, and
Sure.
watching David's video, okay, I didn't think he was boring, but I had other issues with him. So at property, in the example he used, okay, he was using private instance variables for the example. You know, it has to do with Hogwarts and all of that.
Yeah,
And,
yeah.
and so I didn't know if the decorator at property meant that in writing this program, I had to use private instance variables, you know, to protect the variables or not.
Okay, I got your question now, and I think the answer is yes, because this is like best practice in object-oriented programming in general. The idea of encapsulation, which means that you cannot access data inside a class's object directly. You have to use what's called like getter and setter methods to do that, because getter and setter methods provide you with certain security and error checking that you can break if you had the ability to access those attributes directly using the dot notation. And in many programming languages like C++ and Java and what have you, you can actually prohibit this type of behavior by naming those attributes private. When those languages see the word private, they sort of say, okay, if like the programmer tries to access this from outside, I'm going to give him an error and say, sort of you yourself call those attributes private, so why are you now trying to access them from outside? Python, for whatever reason, I don't know why this decision was made. They decided to go with, you know, it's what David was calling an honor system. The idea is that you can sort of set them as private, but if you want to break your own code, you're welcome to do so. It's like your problem. I'm not gonna like handhold you and tell you like Nate, you set those to private, so you can't do that. Sure, if you want to do it at your own risk. And that, on the one hand, is a problem with Python because it sort of gives you more leeway. It's more liberal in that sense. But then on the other hand, there is a certain plus, I guess, to that liberty. If you want to do something, you can do something, but you just need to understand the consequences of doing it. So getting back to your original question, I do believe that using these properties means that they were expecting you to have them private and not to be accessed from the outside.
Great, that's helpful. Okay, and
Okay,
then
sorry if I was a bit long-winded.
no, it's all very confusing. So you're really clarifying a lot, Alex. Thanks. And so
Okay, yeah, I prefer to over-clarify than under-clarify.
Yeah, with regard to this topic, absolutely. And so I'm sure you'll get into this, but then I gather that when you use the at property decorator, it's something you can do instead of using separate get and set um, um, methods. Is that correct? You don't need setters and getters. You can use at property in order to do gets or sets.
Right. From what I understand here, like the property decorator, what it does, like, hold on a second. So the property is like a getter. So
Yep.
it returns. I'm wondering because they don't actually have setters in the
In
what's it
here,
called?
no, but there was in the lecture.
In the
It's only
template.
annoying that property instead of, getter,
Yeah,
at
yeah, I
getter,
remember
but you have
that
to write
because
that property, but that's your getter. But in the lecture,
right.
there was a setter because he
Sure.
had both getters and setters.
Sure. And since in this one we are sort of also gonna do setters as well, because like we have deposit, we have withdraw, which do work with the attributes. I would assume that we do need to use setters here as well and
You
use
don't.
those. Yeah, we don't.
You don't need to, no.
No, I think that's why it just uses at property rather than, isn't there a different terminology, Min, for using a setter? You can't just say at property, right?
No, because that's your getter.
That's the
Okay.
getter.
Right,
Property is a getter.
So
And
that's
setter is actually setter, which is annoying because this should be getter instead of property. But,
all right. I think I get it now, but you can
Okay.
see why one would get confused.
So I mean, David talked about this, and he said, "I don't know why Python, designers decided to do this way. This would have been more logical, and if this were called capacity getter, and then you would have capacity setter. But instead, for some reason, this is called property, and the other one still would be called capacity dot setter." After you do this, so we could do here something like capacity dot setter and do the setter here. Is that the way it's done? Because I really don't use these that much, so I don't remember the specific syntax by heart, unfortunately.
But aside from the syntax, what you've done now is you've made it much clearer in my mind. Thanks.
Okay. So let's go back to the init method. So what do we need to do here? So we see that this method takes in one parameter or 0 parameters. If it takes 0 parameters, then capacity is 12 by default. If it takes 1 parameter, then whatever is passed is the capacity, and we need to make sure that this is capacity. Well, according to the assignment, it's non-negative. It can be 0, which is weird, but I mean, let's stick to the assignment. Don't question the boss. So what do we sorry, what do we need to do here?
So now you need to do self dot dunder capacity equals capacity.
Hold on. I don't think that we're supposed to do it here like this, because here, I think when you're doing this, you're actually calling Python would actually call the method, which is called like this. So here you actually need to call the method. And when it sees the equal sign, it knows that we have to set it to something. So in this specific place, I don't believe property capacity cannot be set. Ooh. Would it really work like this?
Alex, I think you have to make it private.
Oh, okay. Correct, of course, because in order for this to work like this, you would need to create a setter. So let me just to test this out. So if I do this capacity dot setter, and I say def capacity self and capacity, and here if I write self underscore capacity equals capacity, oh, this looks, so then this would work, because in this specific case this will call the setter, and this will be passed as the parameter here, and the setter will set the private method, the private attribute, sorry, to this value. And this will create the private attribute. And this will not be an attribute at all, because now this is actually a call to a function, to this function.
Sorry, Alex. I didn't hear what the private thing, setting it to private, does.
Oh, one more time, could you repeat the question?
What does setting it to private do?
Okay, the idea with attributes being private, or let's call them public, is that when you create an object, you can actually access the attribute from outside by using the dot notation. So to give you an example, for instance, let's say we would create this jar of cookies. It will be jar equals jar with a capacity of 8, for instance. And then you would be actually able to access, for instance, its capacity like this from outside the function. And like this is sort of fine. There is no problem with this. But in most programming languages, object-oriented programming has one of its tenets called encapsulation, which means that, you know, whatever happens inside that object should not be accessible right like this from the outside, because in a large program this could lead to issues where somewhere mistakenly you do this and it changes the entire program, and then you have no idea where you change it, and you have to look through tens of thousands of lines of code trying to find like a weird place where you change something from the outside. And so there is a concept of private attributes or private methods as well, which mean that these attributes and methods can be accessed only inside the class. So like if you want to change the capacity, you cannot do it directly. You cannot do it like this. Right now I can. I mean, if I do this, then the capacity of this specific object would be whatever this number is, 10 billion. But programmers say this is a no-no. This should not be allowed. If you want to set your capacity to something, you should do it through this setter method. Why? Because you can install like error checking inside this method and see that, for instance, you say that you cannot have a container like a jar of cookies that can store 10 billion cookies. For instance, you say the maximum that a jar of cookies can hold like is 100 cookies. There are no larger jars. And then you would give an error and say like, you can't set it to this. But if you don't do this error checking, that whatever you put here will work. And this could lead to certain problems, let me repeat, in the larger programs. Because this is very weird when you talk about it with a small program that is like, you know, like 50 lines of code. And you're going to tell me, Alex, why are we doing this? We see the entire program. It's easy to see where the mistake is. Why do we even bother? But the idea is that in a large program, you actually need to do this. It will save you hours and hours of time in debugging when you accidentally make a mistake. And then you have to search like tons of code to find that mistake because you allowed, you know, these attributes to be changed from outside, which is sort of a no-no. I don't know whether this makes sense or not.
does, but can we not do the same thing by setting some conditions in the init part of the program?
That's the problem, no, because the init works only when you create the object. So here, I created an object with a normal number. I created with an 8. But then, like David called it in the lecture, he said, I don't remember what the word was, like, you had evil intent. And you sort of went like, ha ha ha, now I'm gonna set it to 10 million. And your init is not into it anymore. So when you do this, it's not connected to the constructor method because it's already done. The object is already created.
Okay.
So you need to have this for every time that you want to change the attribute, and that's where the setter comes in. So a setter is basically like the init method, but for every time that you're trying to do with the trying to do something with an attribute. And actually, that's the reason why the init method also works through the setter. So when this is called, it actually calls the setter, and the setter checks for any errors.
Okay. So right now what the setter is doing is making sure that it cannot be changed outside of the class program.
Yes. So any changes are actually done inside, and here we could put some checks to make sure that we're not breaking any rules that we ourselves, have set upon us.
Yeah. Thank
Okay.
you.
Yeah. Okay, I see, Vicky, you're asking, I had a question about the self underscore construction. Didn't quite understand that in David's selection, the getter and setter property. Can you please go over it again if you have already? I'm off the phone now. What I would probably propose to do now is forget the setter for a while and actually do this for now without a setter, and then return to setters maybe later, because it would be easier to do this first without setters, breaking some OOP, unwritten rules or even written rules, but let's do it without this. So why are you property capacity cannot be set? Because is it supposed to be like with an underscore? It's supposed to be like this. It's supposed to be like this. Hold on. It's okay. It was initially supposed
You need it at the top if you don't have a setter.
Now here I'm confused.
So do you need to have like an if condition before?
Yeah, we will need to have an if condition, but right now so we have this, these are getters. So why is it saying that I cannot set the property here?
Alex, don't you have to set self dot dunder capacity equals capacity?
Yeah, probably. That's the reason. That's where we initially came from. Yeah. Okay, there we go. Right. The reason for this is because we have a function with the same name, and obviously you cannot set that function. Yes. So at the moment, we will simply create a couple of variables which will start with an underscore. And for now, this simply signifies that we as programmers ourselves are telling ourselves that, like, listen, Alex, if you see an attribute which starts with an underscore, please do not change that attribute from the outside. It's gonna be trouble, so restrain yourself even if you want to do it. Please only do this through the inbuilt methods. So Python is not gonna check for this. Python doesn't care how I change them. But this is sort of a bit of a safeguard for myself to tell me that, for now, let's not touch these from the outside. Okay, so we set the capacity to whatever the parameter is.
Alex, sorry. So David also said that the underscore is a safeguard to not change it. Okay. But I wasn't sure exactly what outside meant. I mean, because there's multiple layers of the program. And so does outside mean just outside of that class block? Or does it mean like,
It
you
means
know,
this.
if you were to call it in main or
It means specifically this. So I create an object of the jar class with a capacity of 8, and then I access using the dot notation that specific attribute and change it to 20. So this is changing from the outside.
okay,
And
but if you have a method within your OOP block,
yeah,
right? You may have to call that self capacity again.
right.
And so if you have a method within your OOP block, does that method count as outside?
No, I mean, if you have the method inside the class, that's inside the class definition.
Okay. Um, but if you physically go and change it, Python will let you change it, right? I mean, basically the underscore is just kind of like a sticky,
Yeah,
reminding you that you shouldn't really change it, but
right,
Python doesn't really do anything to prevent you if
right.
you change it, right? Okay.
Yeah, we're talking about this, that in other programming languages like Java and C++, the compiler would actually prohibit you from doing this. But Python is sort of like happy-go-lucky, like, hey, you want to change it, you change it, brother, I don't care. And it's, it's both a plus and a minus. So it's a two-edged sword, I would say. But the idea here is that if I start writing things like this, at this point, I would go as a program, I would go, Alex, you put an underscore there to remind yourself that you should not be doing this, so please do not do this. This is like the maximum security I get here. At least if I don't have a setter, because at the moment we don't have a setter. When we do get a setter, it's going to be a bit more difficult. So we have capacity. What else do we need? So capacity is the maximum number of cookies that can be in a jar. What else?
Don't you also need to initialize the size variable?
Yeah.
Create an instance variable for size. It's also underscore.
Yeah. And what will we initialize it to?
Let's call it 0.
0, because initially we get an empty jar. And I don't think there is anything else that we need to do in the constructor. So the next method we need to do
Wait,
is the
didn't the instructions say like you're supposed to put in some kind of error message if the capacity is below 0 or something like that?
yes. And right now I would probably do it here for the moment. Yeah. So we're saying if capacity, and here capacity refers to obviously to the parameter. If capacity is less than 0, if we go, by the book, then we say raise, and raise is the special word which actually creates an exception, creates an error. It asks us to create a value error. In the parentheses, you can include a string which would specify what the specific error is. So we could write like cookie jar capacity cannot be negative.
Well, okay. So, Alex, this felt a little bit like oxymoron to me, because if you're saying that self underscore capacity should and cannot be changed, right? Why would you even need that flag for capacity less than 0? Because if your capacity is not going to be changed, why would the capacity ever fall below 0?
It will not fall below 0. This error will be, this exception will be raised if at the time of the creation, for some reason, you do, for instance, something like this. And obviously you would not be doing something like this, but if you do like an input, for instance, let's say capacity equals input jar size. Let's go capacity. we do it like an int, and for instance, the user inputs a negative number, then that would lead to an error that would say, you know, sorry, but you can't have a cookie jar of negative capacity if we do this. Okay.
Okay. Also, I think within the instruction, it also said if you somehow initialize a capacity that is a non-integer, it should also raise like a value error.
That one I do not remember. Was that somewhere? Is a non-negative integer though, and it should.
Actually, even I read it that way.
No, I think, yeah, this it may seem this way, but it just says that capacity is not a negative integer. It's not saying that if it's a non-integer, it's saying non-negative integer. So I don't think we need to check the type.
But if you enter a non-integer,
You would get an error here at the moment, for instance.
So
Yeah, you can just have it enter as a string and then check it inside.
So, or you could also say if it is not, if it is alpha, you would get an error. Like if capacity is less than 0 or is alpha, would that work?
It would not work with this alpha because it's not a string. So you need to stringify capacity and check whether it has a dot in there. But I don't think that this would actually have to be done here. I think the class sort of implies that the capacity should be an integer, and we would probably need to error check maybe here. Because I mean, at the moment, for instance, I'm reading this from the keyboard. It's, in my case, it's an integer. If I try to input a float, the error would be here. It would say that that's not an integer.
Got it.
There are different ways that you could do it. There is no one, you know, clear-cut correct answer. You could do it here. You could do it here. You could check for the type of value which is passed. For instance, what you could do, you could say if type capacity does not equal int, you could raise an error. It's going to be a type error. We're gonna say cookie jar capacity must be an integer. And then this would allow us to, you know, raise this exception anytime that the value passed is anything else, a string, a floating point, whatever.
Okay, that's helpful. Thank you.
Okay, why is type here? Do not compare types for that check is, okay, let's do is not. Is that the way it's supposed to be? Yeah, okay, good. So do you think we're done now with this one? I think we covered all the bases. We can probably do the stringified version. In our case, what we need to return during printing, we need to take this this emoji, and we need to multiply it by self.
Don't you need to make it the cookie a string?
Yeah, sure. We need the, of course, we need the like this, and multiply it by size, and then we should get a string of the same number of cookies that we have in size at the moment. So if there are 0, it just prints an empty line. I think that's logical. So then we have deposit, and deposit takes in n as a parameter, like the number of cookies that we're trying to put into the jar. So we need to do a check. What are we checking for here? What's the check? What's the
if it
condition?
exceeds the capacity.
When you say it, can you be more specific?
I think n plus the size, okay, which is like the cookies that's already in the jar, And so basically the number of deposits plus the cookies that's already in the jars, if that exceeds your capacity, it should raise an error. And so mathematically, it's like self dot size plus n is exceeds to self dot capacity.
Yeah, so in this case, we do a value error once again, and we say something like there is not enough space, and we'll leave it at that.
Might you also want to check to see that n's not a negative number, or is that not necessary for this example?
I mean, it depends. You could do that because sort of depositing a negative number is actually withdrawing, and I actually like this. Let's do like if n is less or equal to 0, because depositing 0. Okay. Let them deposit 0, I don't mind. But if n is less than 0, let's also raise a value error. I like your thinking. You cannot deposit a negative number, because otherwise you could get some weird errors if these data will be coming from the user. So if we pass both of these, what do we do here?
Well, then it's self dot underscore size plus equals n.
Yeah, plus equals n, so that should be enough. And withdraw is similar, so we are going to check this one as well. So you cannot withdraw a negative number, right? Withdraw. And also, if what's the condition that we need to write here?
So basically the number of withdrawal is greater than the cookies you have in the jar. That should give you an error.
You could do it like this, yes. Like this. Then you do another value error. You say there
There's not enough cookies.
There aren't enough cookies. So we have these, and now when we have here, this is the setter property, and the idea behind the setter property, as far as I understand, no, this is the getter property. And
Alex, in the withdraw method, don't you need to change the self dot size?
Sure, of course you have to.
One less than n.
Of course you have to. Like last time I asked you, this time you asked me. I mean, you know, working as a team, man. Good stuff, good times. So with capacity, we're basically returning self-capacity, right? And with size, we are returning underscore size. And I think if we don't go into getters, setters for now, we are done. But let's test this. So the program itself, we have, you know, we're inputting capacity from the keyboard so that we can test different hypotheses. We create a jar with that capacity, and now what do you want to test? So this is going to be our first test. So after we create the jar, let's print and see, you know, make sure that the jar is empty. It should print nothing. It should print an empty line. We can actually, you know, do what I think this is. This will help us a bit.
Maybe you want to not convert to an int when you're taking the input.
Here? Yeah, but if I don't convert here, then I will always get this mistake. I need to convert it somewhere into an
You
int.
could convert inside, but then why do you actually check for if it's not an integer? Because if you don't put an integer as an input, then you're just going to get an error
Sure, sure. I mean, that was what I was saying initially. If I don't put an input, the mistake is going to be here. The exception is going to be here, not here. So we added this just to make it more robust if we have a different way of input, not just from the keyboard, but you know, if we do something like this, just to make sure that it's in there. See, it actually says expected type int got float instead. You wonder. Oh, okay, because it's capacity like this, it's even, yeah, shows up here. So no, I just wanted to add maybe a phrase at the beginning, like you know, jar and plus whatever's here, just to see at least that something is printed, like this part is printed. So what's the next thing we want to do? Probably deposit something into. Let's do. How many cookies would you like to deposit? We get n, and then we do jar.deposit, and let's see where that takes us. Then let's check for withdrawal. How many cookies would you like to withdraw? Jar withdraw n, and once again print the result. I don't think there's much else to check. We can just do it with different values input from the keyboard to check for all the errors, etc. But I think this is like this is the testing suite we have. So let's run it and check. Input cookie jar capacity. Let's say it's, I don't know, 8. So now we have an empty jar. We have created the jar, but there are no cookies in it. So let's first do this without any mistakes. So how many cookies would I like to deposit? I would like to deposit 6 cookies. And as you can see in our jar, we have 6 cookies because we increased the this attribute by 6 in our deposit function. We passed this test, we passed this test, so we got to this part. How many cookies would you like to withdraw? Well, let's say I would like to withdraw 4 cookies. And now you see that we have a jar with 2 cookies remaining. So if we do things by the book, we do not make any errors, then the program works as expected. But now let's check what happens if we do some weird stuff. So for instance, now here we will not ask for capacity. Let's try doing this with a floating point number. And as you see, we immediately get a type error, which says, you know, cookie jar capacity must be an integer. So this error worked. We're sort of going, okay, nice. Let's go back to what we had before, and let's try entering a negative capacity. Let's say that it's going to be -10. And we're going to get an error which says value error, cookie jar capacity cannot be negative. So the second fail-safe works as well. Cool. Let's do like 10. We have an empty jar. How many cookies would you like to deposit? Let me try to deposit more cookies than are feasible. Let me try to deposit 12, and I will get value error, there's not enough space. So that one's working as well. Okay, how about I try to deposit a negative number, like -5, and I get an error, you cannot deposit a negative number. So both of these, not these, but these, both of these work fine. Okay, coolio. Let's try depositing something normal. There we go, we have 8 cookies. Now let's try to withdraw something incorrectly, like -4. And we get you cannot withdraw a negative number. Nice, that works. 10, 8, let's try to withdraw more cookies than we have in the jar. Let's try withdrawing 9. We get error, there aren't enough cookies. Is there anything else that we can do to try to break it? I don't think so. I think we tried all the possible variations. We got all the errors that we needed to to get.
So
So I
Alex,
think, yeah.
in David's setup of his problem, he wants us as students to set up a separate test file and then to use PyTest in order to test it. So that's a separate topic, but I'm curious if you're going to go into PyTest at all today, and if not, and would you give us perspective on what you think of PyTest versus doc tests, and what are your preferences there?
Where
Test
does
is
it?
better, but you don't know, like you can't go into it now because you have to watch another lecture.
Yeah,
But
because
yeah, we're
I'll.
supposed to write our own test with like, PyTest, assert and stuff, but people who haven't done CS50 wouldn't know that.
I'll be frank with you. I do not know PyTest, so I do not have the knowledge to actually say whether it's better or worse because I have no clue how it works. I've never used it.
Okay.
So I'm sorry. That's the answer for you right now. I'm just doing it, yeah, very old-fashioned style. Just write some code and see whether I can break it or not.
So Alex, in your own programming, when you're doing testing, do you actually make use of doc tests, or you just do what you just did by
Unfortunately, I do what I just did, and I wouldn't say it's very good practice, but since my programs are relatively small, and since I'm the only person writing those programs, so I don't write programs with someone else, it sort of works. And honestly, I'm just too lazy to write good doc tests or what have you. If it were a situation where I knew that I would have different people working on a project, and I would have to write doc tests to make sure that whenever we put our code together, we're not breaking each other's codes because we misunderstood one another, or some errors crept in that I'm not aware of, and it's not my code, and I'm not a big fan of going through another person's code. I mean, that's not my job. So then tests become important to make sure that it all works. You sort of give person a function with tests or a class with tests, and that person has to figure out, if something goes wrong, then he has to pass the test to make sure that he is interfacing with your whatever your function or your class or your methods correctly. But yeah, since I'm not a professional programmer, I don't have the necessity to do this, so I don't.
So Alex, I'm just guessing that for more complicated programs where you're importing one module into another module, maybe it makes sense, I don't know, to have something like PyTest, which simplifies a little bit, how you run the tests, and have it go over the entire program, or bigger module, which includes other modules in it. Maybe that's the value of it. I don't know. I'm just guessing.
It's probably that's it. So as you can hear probably from the way I'm answering, I'm sort of apologetic for not doing it the way it should be done, because obviously like tests like this add a lot of value and save a lot of time in finding errors. I'm just explaining why I'm not doing it, but that I'm not saying that this is the correct way to do it. This is unfortunately an area in which I'm not as competent as I would like to be in order to actually teach it. So that's why I'm saying openly and frankly, this is not a topic that I'm good at, so I'm not gonna try to look as if I know this and teach you some, crap. I wouldn't want to do this. So this is something maybe, we could find someone who's actually good at testing and could give us a lecture on testing. I'd love to, come to that one as well. But that's unfortunately not me. I only know the basics. Like I understand more or less doc tests.
You're just a solo developer way. It's fine.
And I'm not even a
believe there will
developer, let's
be.
be honest. This is like a thing that I do for fun. So calling me a developer is sort of over, making me sound better than I am.
I mean, you are a developer. It's
Yeah.
Well, what you are is a good teacher, Alex. That we know.
That I can that sign up for. For developer, I'm not gonna sign up for that. No way I'm a developer. A wannabe developer, maybe, but not a full one. So yeah, I saw Vicky. You're asking have I explained getters and setters yet? No, because like this one we did without the explicit setter. We have the two getters here, but they are sort of useless without the setter. So
I thought I
I
fell
would.
asleep or something. So
Sorry.
no, no, like I thought I like zoned out or fell asleep or
No,
something.
no, you didn't. You didn't. I would probably try like using the last, like in my head, I see it's like almost 12, like your time. So like in the last 5 minutes, maybe quickly doing the setter here and go through that. So as we remember from David's lecture, the syntax
My
is not.
understanding is that they're not actually useless and you cannot directly access the attribute anyway. So if you were to try right now and change it outside without the underscore, that is, because the underscore, of course, bypasses what we're trying to do, then you wouldn't be able to. So if you did
Sure,
the jar equals
sure.
jar, the
Right.
class
I
8.
would not be able to do this. Capacity equals 12 for the simple reason that capacity right now is not the attribute. Capacity is the name of the function. So you cannot set this to the function. But the problem is that I could do this.
Yeah. I mean, that's the, you can always do it with the underscore, which is.
Right. But the idea with the setter is that you can include all these checks inside the setter instead of in the init method. So every time you're trying to set something, you go through these checks, even if you're trying to do it from the outside. So basically, you cannot forbid the programmer to access this from the outside. You cannot. Python is very lenient in this sense. It says, you want to do it, come on, do it. I don't mind. But at least if we do a setter, and the setter would look like this, we would call the property as we tried capacity dot setter. The same function capacity with the only difference that now it's going to take another parameter. So it's going to be one parameter instead of 0 parameters. In this case, we can actually take all of this, take it from here, and put it here. So we're going to check whether, let's call it capacity. We're going to check if capacity is not an int, and if it's not, we're going to produce one error. Here we're going to produce another error. And in case both of these conditions, we pass both of these conditions. So here the only thing we do is I think we'll leave it like this, right? So it's capacity. Yep. Yeah. And now what we do here, the only difference is here we do not use the underscore, because actually here now with this we are calling this setter. And now if for some reason somewhere in our program we try to change capacity, although I understand Vicky said, how can you change the capacity of a jar? A jar sort of doesn't change capacity, but if for some reason we decided to change this capacity somewhere else or outside the program, we would still have to go through these checks before changing it, but we would still be able to change it, unfortunately. So we will not be protected from this. And with size, we can do the same. We have size setter.
If it raises an exception, it like aborts the program, and so how could you change it unless you go in physically and change the number?
No, I mean, I would still be able to change it to something legal outside of the class.
I don't know what that means.
Okay, I'll show you. Let me finish the second setter, and I'll show you the second setter. oh, there's not much checking here, like the size. Well,
So
actually, the size also can't be. We can change here. We can check here that if we set the size, that it's actually not negative, and then it does not exceed the capacity, because that would be the two logical things to check for if we're setting the size.
So
So
Alex, okay, setters and getters have to exist together, right? I mean, you can't have just a setter.
no, you
Um,
can. We just had a getter without a setter.
so I guess can we backtrack a little bit and like what is the function of the getter versus the setter?
One more time.
Okay, if they don't have to exist as a pair, what is
Yep.
the function of the getter versus the setter?
The getter is a function which returns the value of an attribute. A setter is a function which changes the value of the attribute. So that's why they're called getter and setter. One gets the value for you, the other one sets the value for you.
Alex, wouldn't it be true that getter would mostly be used only when you do have an underscore um, um, uh, um, privacy set, and otherwise you wouldn't need it? Or am I misunderstanding that?
No, sure. I mean, the logic is that you would use this. I mean, you don't have to use the underscore. You can use anything else. Once again, there is no. This is convention. This is not a rule.
Well, I got
So
that. But if you are going to use the underscore, then you do need a getter in order to change it, in order to calculate,
yes.
correct?
Well, at least I'm not sure about the single underscore. I believe with two underscores, that's the case, because there is something which is called, if I remember correctly, it's called variable mangling. It's a very funny thing that Python does. When you put two underscores for an class attribute, it mangles the name of that attribute so you cannot access it from its outside. So it stops being called capacity and starts being called something like jar class capacity or something. So the name actually becomes different, and not because you decided to name it differently, but because Python internally names it differently. So whenever you try to access it from the outside, it will tell you there is no such attribute, because actually the attribute is called differently. But if you know the logic by which these names are created, the mangled names, you would still be able to change it. Python would not be able to stop you from doing that.
Yeah, you're still able to access it. So it's basically
Yeah.
you have
So
the
there is.
flexibility to protect yourself from yourself,
Yeah.
but if you really wanted
Yeah.
to, you
You
can
can
still.
always cheat yourself, yeah, and do something crazy. Python is sort of like, yeah, you're a crazy guy. You want to do it? Fine, do it. Your problem, not mine. So here we have size cannot be negative, for instance. And if, for instance, we say if size is more than capacity, we can also raise the value error. There is no space, or not enough space.
Alex, I don't get why do you need a getter? Why can't you just have the setter if all the getter does is like returning an instance variable?
Because you can actually write something more than this in the getter. So what we have right now is the simplest getter that you can have. But in some cases, you, for instance, would like this information to be returned in a very specific way, not just the size,
What?
for instance. For instance, you would want to return a string which describes the size. I don't know why. I mean, it's once again, it's a design decision. But this then the getter would make sure that you get the information in the format that you want as a programmer instead of just the value that's stored there.
So I guess if I can kind of pontificate about what the getter is doing, okay, it's taking this self variable and then it's returning self size to where? Where is it returning it to?
Yeah.
Well,
Sorry, I don't know whether that's my internet or your internet, but you're dropping out for me. I missed half
well, my question is
of your
in the
sentence.
getter, okay, the getter is getting the self and then it's returning self dot size, but where is it returning it to?
It's returning it to wherever it's being called. So, anytime when you are doing
Anytime you see self dot underscore size, it's actually automatically calling the getter and the setter.
No, I think it's that if you do a protected definition for the instance variable, in order to access it in the code outside the class, you have to use a getter. Isn't that it, Alex?
let
don't know
me
what that
check
means.
because
I
hold
have
on
no
one
idea.
second. If I do this, okay, so basically now I believe we do not need to use the underscores anymore. Let me except for sorry, here we do need one, which was the previous one. Just give me a second. Capacity, size. Yeah, but then it's yeah, sorry guys, I'm already a bit, muddled, and with all these underscores, I'm getting a bit. So this was size.
You want to postpone it until next week? We could have like another 4-hour session next week.
Oh my God. No way.
No one is forcing you to be here. Come on, man.
No,
No, I mean
I
it's your
have to
time,
be
Alex.
here.
You're the one
Yes,
I know,
sitting
because
here. Like normal
everyone
sections
I'm
are
the
got
1 hour.
crazy
merged
one.
to the Zoom. I cannot leave.
I
I'm the
mean,
crazy one.
you can just leave and leave it on, but it's Alex's time really, and he's giving way more than we deserve, really. Like,
I
instead of 1
know.
hour per week sections, which was was supposed to be like, at least in
Yeah,
code in place, you're sitting here like 4 hours.
I
It's a lot.
know.
It's a
All
Dunder
without
Mifflin
Crazy,
pay.
situation. Yeah.
crazy, crazy.
Every time I see Dunder, I remember Dunder Mifflin in the office. That's
I thought it
yeah.
was just me. Every time
No,
you
no. But now at least you know where the Dunder in Dunder Mifflin comes from.
I do indeed.
Yeah. So, okay, it may sound like a good idea right now, to maybe like put this on hold because this is the 5th hour and I'm going a bit crazy already. But let's quickly run it the way it's done right now and see whether it's still working. So capacity, deposit like 6 cookies, it's still working, withdraw 4 cookies. 2, okay, we're done. So basically the thing that you're asking me, Vicky, you're saying like, why how would you be able to do stuff from the outside? So for instance, if I try to do this right now, something like capacity equals 100. If we didn't have this setter here, I would actually be able to make the capacity not even 100, like minus 100. I would actually, despite initially having some checks in the init method here, because I did not have any way to prevent this further on. because this is valid syntax.
Yes.
I can access using the dot notation any attribute and change it to whatever I want. But now, when I have a setter here, I think it should give an error unless I screwed something up, which is a distinct possibility. Yeah, of course I did. Would it be like this then? 12, 8, 5. Yeah, there we go. So if I try to access this using capacity without the underscore, then it would run through the setter here. It would see that it's a negative number, and it would say, this is not possible, you cannot do this. So,
but the reason why, if you were to add the underscore there, is because Python would still allow you to change it, and
Yeah.
thus it bypasses the setter.
Yeah. So if I do this, Python would still say, "Oh, you want to do that, Alex? Sure, go ahead, be my guest." And you cannot prohibit the person from doing
And
this.
okay, what is the getter doing in this series of executions?
In this specific one, nothing in particular. So for instance, if I were to say print jar capacity at the end, 12, 8, 4, it would just print 12. So this would return the number of the capacity of the jar. So at the moment, the getter itself doesn't do anything special. But I could, for instance, for whatever weird reason, do something like this. The capacity of the jar is self capacity, like this. And let's see where that takes us. Not supported between. Did I mistype something? I think I mistyped something. No, I did not. Why? Oh, okay. No. Well, it's not going to work right now for the simple reason that I'm using the getter to get the value, which is checked here, and of course it's a string. So I don't think I'd be able to give you a good alternate use of getter. Sorry.
I think she just wants to know what the getter and setter do, but is
Exactly.
confused on how the order of things work, and why you can use one without the other or whatever. But yeah, basically getter protects you from, prevents you from directly accessing attributes, and not really, because you can always bypass it, but that's the idea. And these attributes, which have an underscore, is what we call private attributes, which again, they're not so
Right.
private. Even when you
I
have double
understand that
underscore,
part.
they're not so private. And so when you call the self.capacity equals capacity, what you're doing is you're calling the setter to set that private attribute, the underscore capacity. Because you don't have underscore capacity there, right? It's self.capacity equals capacity. And then in the setter, you set that self.capacity, the underscore, the private capacity, we'll call it, self.underscore capacity to capacity. So it's like equal to capacity. And then the getter returns that after. So it's like the call is to setter, and then
So
getter.
I guess you're saying that the getter is setting where you have capacity to the underlying capacity, and then and the setter is like marking the error message.
Well, yeah, in the setter you have the if check with the raise
Right,
value
right,
error or
right.
whatever.
Yes, I think I understand better what the setter does, because basically the setter is the error check, okay? But I
Right,
don't
yeah.
really understand what the getter is really doing and why the getter is necessary. Because Alex just gave us an example where without the getter, your error check still works fine. So,
It was without the setter. We had a getter, and he had the check in the initial init, the dunder init.
Yeah, there we got it was a different reason. There we got because now the getter was returning a string instead of an int, and then it was trying to add a integer to a string, so that led to an error. It was not our error checking.
that's okay. I think, I mean, I don't think I'm gonna be able to like absorb that much more today. I can take a look at this again, with a fresh pair of eyes, um, like tomorrow or something, but
Sure. There is just one more thing that I wanted to show you very quickly about the double, the dunder attribute. So I created just whatever class, it doesn't matter, and inside this class I have an initialization method which has a attribute which starts with a double underscore, and I set it to whatever random number, like 13. The reason I'm showing this is because this is the situation I was talking about, where if you launch this, you would actually get an mistake, you would get an error, and it says example object this has no attribute double underscore attribute. And you sort of go, what do you mean it doesn't have? Here, it does have it. So this is a more strict method for Python to make it even like not a private, but it's like really private method. Because in reality, it mangles the name of this attribute, and the real name of this attribute is different. And you can actually find it. I don't remember. I mean, do you remember how you can check all the attributes of an object? Because there is.
No, I mean, I think I saw in somewhere that you can do like underscore before the class and the double underscore on the attribute to access it. I think it was. But I've never done it, so I wouldn't. I think it was like underscore example and then underscore underscore get for the like an underscore before the class or the object. I mean, you're using.
Maybe it's get state. Let's try get state and see what it gives with get state. None. Okay, that's not very helpful. All right, guys and girls, I propose, like David says, I would propose to end today's meetup because it's like the 5th hour and it's a bit too much. So let's stop here. And I mean, we do have one more meeting, which is in a week. And we'll be doing the Bajillion search engine. Once again, there is a part of that assignment which is interesting to do. And there is a part of that assignment which deals more with the graphic interface, which is more, about HTML and JavaScript than it's about Python. So we would probably, we should do the first part and the second part if optional, if you really want to go into it. Moreover, the reason why we decided to do Bajillion search engine after classes, because it requires knowledge of classes and the syntax. Without it, you cannot do the last part, which is the optional part. So now you have like more instruments at your disposal to solve that problem. But once again, like I said, it's not a necessary thing. And I think we're done for today. Thank you very much for sticking through this, because I see like most of the people really stuck through for 4 hours. Come on, people, you are crazy in a good way. So we will see you. You're dunder for today. I am totally dunder for today. That's true. That's true from both sides. So we'll see each other in a week. And to some of you, good night. For me as well. For some of you, have a great day. And until we meet again. Once again, if you have any questions, drop them in the forum. I will answer them to the best of my ability. I will be traveling next week, so I will not be available like all of the days, but I will try to answer any questions that I see. All right, see you everyone. Bye bye.